what are the biggest drivers of fructose in our diet? And are there healthy foods that are out there that people are consuming that they think, I'm putting health in quotes, they think these foods are healthy or we've been marketed to that they're healthy, that actually might be a big contributor for a lot of folks who think that they're in the healthy category, but it's a big driver of their uric acid levels being elevated?
Let me take a step back. And that would be, if we're going to look at answering your question through the lens of uric acid, then by all means, step one would be to see where you start. I mean, if you call your doctor and say, hey, by the way, what was my uric acid 2 months ago when I was in your office? And she tells you, well, it was 6.8. That's valuable information. Now that you know that uric acid above 5.5, and there's nothing magic about 5.5. This is analog. 5.6 is worse than 5.5. Doesn't mean that 5.4 is perfect. The only thing that's digital really in medicine is, I think, being pregnant. You either are or you're not. You're not kind of analog pregnant, right? I think that, so first would be, where are you on that scale? And then what are the changes that you need to make? Our ancestors and primate ancestors to this day, primates will consume a lot of fruit, pounds and pounds of fruit as the winter would approach. Bears, for example, eat pounds and pounds of berries as a stimulus to make body fat to prepare them for hibernation. A hummingbird at times, what is a hummingbird? If you want to have a hummingbird outside your house, you put out sugar water. Hummingbirds primarily eat nectar. They might eat some insects, that's true. But at times before a long journey, the hummingbird is the fattest animal on the planet. Think about that. The hummingbird. You're thinking of an hippopotamus or an elephant, blue whale. A hummingbird can be 40% of its body weight fat because that's an energy store. So, the notion that fruit containing sugar, that's where fructose name comes from, is a bad thing. I think, again, it's the context. The fruit contained in an apple a day will keep the doctor away. 2 apples a day, not a problem. 3 to 4, you begin to think about it. But the delivery system of fructose, along with bioflavonoids, fiber, and vitamin C, which help to mitigate against raging uric acid through a number of mechanisms that we can talk about, I think in that context, then whole fruit is a good thing. Our ancestors would not be migrating and stumble upon trees with fruit juice bottles hanging from their limbs, right?
Apple juice, orange juice, whatever.
I come from Florida, the orange juice capital, and it's not what you want to be consuming. You don't need 48 grams of sugar in a serving, it can be, as depending on the size of the serving, as high as 36 grams of sugar in a 16-ounce glass or 12-ounce glass of fruit juice, or 16-ounce glass rather. That's the same as a can of soda. Why would you want to do that in a way when you're drinking that sugar that it suddenly raises fructose in your bloodstream, triggers this mechanism we've been talking about to make uric acid, signaling your body, get ready for winter. Fructose in an apple, 5 to 10 grams, delivered with fiber, delivered with bioflavonoids, delivered with vitamin C. These are offsets against elevating uric acid. Now, how aggressive do you need to be about limiting fructose consumption? I think everybody needs to take a pause and say, hey, there's fructose in my diet in fruit juice, which I thought was good, but also in the sauces, the various condiments I'm using, out to dinner. You want a piece of fish or whatever it is, but then it's the drizzle, right? It's always creative on the meal that you get, oftentimes sugar sweetened. That's why we like it so much. Why we like sweet is because it's a powerful survival mechanism. There's not a person on the planet who doesn't have a sweet tooth. Do I have a sweet tooth? I absolutely do, and you do too. Admit it. We love sugar. We love that taste because it's a survival mechanism. It tells us, eat that food. A, it's safe. In nature, sweet foods are generally not foods that have poison in them. They're not going to kill you. And B, it's been in our interest to eat those foods that are sweet because they are ripe and they are highest in their nutrient value, and they're going to help us make fat. So these days we have to take our primitive brain offline and bring online the prefrontal cortex, is what you and I talked about last time. Get rid of this disconnection syndrome and bring the adult back to make better food decisions, and say that foods that are high in fructose we want to avoid. Now, the only three things that turn into uric acid in the human body are purines, which are the breakdown products of DNA and RNA, fructose, which we've talked about, we can certainly talk more about that, and then alcohol. So alcohol is metabolized in almost an identical fashion that fructose is metabolized, almost, peas in the pod. It consumes energy, it destroys ATP and forms AMP. So it's an energy consuming event that locks us into this metabolism side of AMP deaminase, make fat, store fat, increase blood sugar, as opposed to our AMP kinase, which is what we want to activate to make us thinner, burn our body fat, not raise our blood sugar. Alcohol does the same thing, but there are some nuances as it relates to alcohol. So what the research shows is that wine, for example, more so in women than men, is either neutral in terms of uric acid production, or may, in women, be associated with a lowering of uric acid. Not so with beer. I mentioned that earlier. That was your first question, as I recall. Why? Because beer contains alcohol, but it also contains purines. From what? From the brewer's yeast. And these purines are metabolized into uric acid, so that tells the body to make fat. So now you fully grasp why there is a good understanding about where the beer belly comes from. It comes from the fact that beer has alcohol and purines making uric acid, saying, you better make fat right now because winter's coming and you're going to need this fat. Hard liquor as well raises uric acid, not to the extent of beer. But the good news is there is now beer made without purines to help people with or manage their uric acid. So we're coming along.
Two quick thoughts on that. I had shared with Dr. Johnson, again, you dedicated the book to him and wrote about a lot about his research in there. I was watching this documentary on sumo wrestlers in Japan, and to put on, to put on that sizable amount of weight that they need to be competitive, if they're going to be a competitive sumo wrestler, it's actually very tough for them to get that size, especially with the frame of the body type that they might be having in the Japanese culture. And they have these dormitories, like literally boot camps that people go to who are sumo wrestlers in training. And one of the ways that they encourage, they've learned just from, hundreds of years as sumo wrestling has been around, they've learned that this is the fastest way to put on body fat. So in addition to having, 6 to 8 servings of rice throughout the day in these big bowls, right? So they're probably double servings, so they're probably having more.
Which probably are not really contributing significantly to their weight gain.
Even though it's spiking their glucose throughout the day?
It is, but I mean, the other, and that is setting that's taking advantage of then what the fructose is doing. And understand that their use of sugar, table sugar, that's 50% fructose.
Got it. So in addition to that, so maybe the rice isn't doing that as much. And I have a couple questions on the rice thing. Is at night before they go to bed, they drink a big pitcher of beer. And then they go to sleep with basically all that alcohol in their belly. And it was specifically, it's beer, because they found that that's what helps them put on that massive amount of weight that they need to put on in a very short period of time.
It's true. And they're genetically predisposed even more for these issues of weight gain. When you look through Polynesia and Micronesia, those areas, there is something called Pacific hyperuricemia, where selective pressure of these groups for 3,000 years having these long transoceanic migrations to colonize Micronesia and Polynesia, selected out those individuals who survive who could make more body fat on the limited food resources that they had, who didn't need as much water based upon their genetic predisposition. So it selected out those individuals to make more fat, and fat, the metabolism of fat creates gram for gram water. So having higher levels of fat reserves is what, the blue whale doesn't find fresh water. It makes its own water from its body fat, as do we. Again, we make a gram of water for every gram of fat that we metabolize. We make only, the ratio with respect to protein is about 40% of what we can make in terms of water in comparison to fat. So it explains then why in places, in Polynesia, for example, you see incredible rates of obesity and other metabolic issues like diabetes and hypertension. This is a profound manifestation of an evolutionary environmental mismatch. These people up until 150 years ago there are some images of these people. They were thin, robust, and suddenly when our diet was introduced to them, which, now they import most of their food, they're not growing it locally, you see the consequences, the incredible rates of obesity. And it has a term, Pacific hyperuricemia, because the uric acid levels are far higher than we see in North America and in Europe.
Yeah, and percentage-wise, you look at like America, Samoa. I mean, the highest body fat percentage of any country in terms of total number of, population that is obese, and because their bodies, again, as you're mentioning, predisposed to packing on the weight, and with the military bases and everything out there, all the American food and the processed food making it out in its direction. I want to go back to rice for a second, because I think that, you're an advisor to Levels. We've talked about them on the podcast before. We've had Dr. Casey Means on the podcast. And I think as a lot of people get fascinated, they wear continuous glucose monitors, whether it's from Levels or all the other great companies that are out there, they start to pay attention to a lot more of how elevated glucose and insulin resistance and how that plays into all different aspects of metabolic health. You said something about the rice earlier, which is you were saying that may not be, even with that large of a consumption of rice, a primary driver of weight gain when we were talking about the sumo wrestlers. Tease that out a little bit more. How do you think about some of the conversations that we've been having with people using continuous glucose monitors, and how the uric acid lens would add another layer on top of that? Because just to bring a little bit more background in this, often people will see things that are high in purines may not be foods that elevate their blood sugar response.
Immediately. That's
Immediately, right? And I would love for you to talk about that. So then sometimes the thinking is like, wow, okay, great. Red meat, grass-fed beef, these foods, maybe I'm starting to make more of my diet out of them and less so these spikes that I get from often some of the carbohydrate sources of things that are out there like rice. So put your lens on there of how you see that world now.
Sure. So again, we live in a time of personalized medicine, and it really depends, if you're talking about continuous glucose monitoring, what is your individual response to any food, whether it's almonds or rice or sardines? How does that affect you? And that's why there's such beauty in understanding that biometric of what is your glucose measurement moment to moment. It's such valuable information. But the notion that the sumo wrestlers are getting fat because they're eating bowls of rice, I think there needs to be more in the equation, and you characterize what it is. They're targeting the uric acid pathway to help them become more insulin resistant. They're all of them are, I'm not going to say all, but I'd be surprised to find a sumo wrestler who's not diabetic or nearly diabetic. I would suspect, based on what they're doing actively to gain weight, that these guys are hugely metabolic disasters, basically, and they know it. They're willing to pay the piper up front. But the reason I made that statement is it's going to take more. And will having a bowl of rice spike their glucose? It will, but it's in the context of how they've already dysregulated their metabolism through the consumption of alcohol, through the consumption of high purine foods, and certainly through their consumption of free fructose, meaning not necessarily fruit-related fructose, in fruit juices, in beverages. Once you set the stage for that level of metabolic dysfunction, then when you add in the breakdown products of starch from their rice, elevate their blood sugar, of course it's going to increase their lipogenesis, their creation of fat. But it's not the rice in and of itself. The other factors have to conspire to really set the stage for that level of fat production that these individuals are experiencing. So what I'm saying then is that many individuals who are metabolically intact can afford to have a serving of rice and not see a dramatic spike in their blood sugar levels. And I encourage that. I encourage, through the use of CGM, that you determine which are the foods that seem to be spiking my blood sugar. And you'll find that the more metabolically improved you become, the more you're able to tolerate certain foods that perhaps you couldn't in the past, like that serving of rice or like that serving of potatoes. But it's when you're metabolically dysfunctional, as brought on by these other indiscretions, that's a kind word, these other lifestyle choices that leverage or are seen through the lens of this paradigm, the fructose to uric acid paradigm, that really cause you to be intolerant of the rice or the other carbohydrate-rich food that you may be consuming. So that's why I made that comment about the sumo wrestlers. It's certainly not that, you know, this is a study whereby all they're eating is rice. I think animal research, rodent research would indicate that ad libitum consumption of carbohydrate-rich foods doesn't really cause significant weight change in rodents. It is when fructose is given, as Dr. Johnson's research clearly demonstrated. When he wants to produce glucose elevation or more appropriately insulin resistance and even hypertension in laboratory rodents, he gives them fructose. He adds fructose to their drinking water. Then, intriguingly, what he's done in rodents is he has blocked the uric acid production by giving a drug, allopurinol, a gout medication, that then allows these rodents to have high caloric intake of fructose, but not make uric acid, and they don't get metabolic issues. He has repeated those studies in human beings as well and noted the same thing. So we know it's not just the calories, for example, coming from the fructose. It is dependent upon this mechanism of activation of the uric acid that then said it's the danger signal, winter's coming, sets the stage for the weight gain, the elevation of the blood pressure, the elevation of glucose via gluconeogenesis and the insulin resistance. And that is the context in which I answer that question about the rice in the sumo wrestlers. So, and you know, what is, in thinking about it, what is so exciting is that this research is going on now around the world. Japan is deeply involved in uric acid research to the extent that they are, in fact, treating people with certain metabolic issues by giving them uric acid lowering medications. And that research is happening around the world. Places like Turkey and Japan and certainly across Europe. In Drop Acid, we've reviewed more than 400 of these studies. And it's really quite profound how that's going to be translated and now is being translated to, you know, the interaction with patients, saying that, you know, here's yet another thing we need to consider in terms of getting you back on track so we can help you lose weight, help you get your blood sugar down.
One thing I just want to pin is that as so many people, yourself included, and my business partner, Dr. Hyman, and Casey, who we referred to earlier, and many others, are really starting to, and have been for quite some time, talking about the role of insulin resistance, metabolic health. And then as CGMs have become more available, a lot more people are like tracking it and making changes. And it's like the uric acid piece is another level of sophistication, going more upstream.
It is.
And helping people understand that, you know, we don't want to be in the place where we're, you know, sometimes people get into the pathway of measuring their blood glucose. They're afraid of certain foods, right? They're afraid of, you know, carbohydrates. They're afraid of certain fruits, other things like that. And really what we're talking about is, again, metabolic flexibility and your ability to uniquely be able to handle these foods, because regardless of what people think, it's very evident just looking at it. Human beings ate a lot of different things, a lot of different types of whole foods diets, right? As long as it's whole foods, they've eaten a lot of different types of whole foods diets throughout history. And there's still modern day hunter-gatherers that eat different forms of higher fat or higher protein or lower, you know, or higher carb, whatever it might be. But I want to just pin that point that If you've been hearing about metabolic health, and we've talked about it a lot on this podcast with some of the top experts like yourself that are out there, really you have to understand metabolic flexibility and think uric acid and metabolic flexibility go hand in hand, right together.
No question. And again, it's just taking this step back and looking at our evolution, looking at how our day-to-day lifestyle choices play against what we are dealing with. What is our physiology, and what is our physiology geared at? And our physiology is geared at survival during times of food scarcity. And when you appreciate that, when you understand that moment to moment your body wants to survive and make the most out of the food that you are going to consume, that we have, as Dr. James Neal described 60 years ago, these thrifty genes, meaning that we want to make as much fat as we possibly can to keep us alive, because, you know, we're hunter-gatherers. There may be, you know, weeks that we don't have food. And so we have that physiology. And this is a very new nuance to that understanding. It takes us away from being very dogmatic about eat this and don't eat that. Because now we have another lens, as you characterized, to look at our lifestyle choices beyond food, look at what we decide to do, how we sleep, for example. We know that not getting enough restorative sleep, another time for biometrics, raises uric acid, or at least is associated with an elevated uric acid. That exercise helps to lower uric acid, but not too much. We know that an aggressive period of exercise, more than you might normally engage, will transiently raise uric acid. Why? Because you'll break down muscle,
your own
liberate
muscle breaks
purines.
down.
Matter of fact, 2/3 of the purines floating around in your body aren't from the foods that you eat. They're from your own muscle breakdown and other tissue breakdown. But even fasting will clearly elevate uric acid. But what the research shows is that that's transient. And that ultimately, as we've talked about many times, the net benefit at the end of the day, or however many days you fast, is positive, that you've done yourself some good. That period of ketosis, for example, ultimately is a good thing as it relates to your metabolism and uric acid and the downstream issues related to uric acid, like insulin sensitivity. While you're in ketosis, your uric acid level may actually go up, as you might expect when you're catabolic.
I want to ask about sleep and exercise. I have a couple questions about those. Before we do, just last couple questions on the food side. We've talked about purines, right? So if you look at from evolutionary history, you know, we talked about fructose and why, you know, when fruit would come in the late summer, the fall, it's designed to fatten you up. And because again, winter's coming and you need fat around you to survive. Fat is a storage. It's the energy pack. Same as you charging up your Tesla or your iPhone or whatever. It's the energy pack that lets you make it through. So we understand the role of that. Where do you think the role of, not the intentionality of, why is it that purines play the role? And surprisingly, you know, some of the foods inside of your book that you'd say that maybe we should be really considering limiting in our diet, a perfect category is anchovies. So anchovies, typically, you see this term used a lot in functional medicine, smash fish, right? Sardines, anchovies, mackerel, and such and such. So herring. Sardines and anchovies are high in purines. And how do you think that fits in? Because traditionally we've been told, I even wrote a whole newsletter, that we're trying to limit the bigger fish that are out there, the tuna, other things, because of the plastics that are in the ocean and then feeding on smaller fish, potentially the mercury that's also there too. And there's a lot of reasons why we would want to go towards smaller fishes. How do you, why is it that anchovies and also beef, in this instance, red meat we're talking about as well, why are those foods, do you think, that would have that reaction inside the body?
Well, it's a nuance. It's a nuance that we didn't know about before. I mean, you know, there was a time, perhaps if you would have interviewed me 20 years ago, that I would have said, you know, we've got to be on the lowest fat diet that we can be on, because as we all know, fat causes heart disease. We learn more about what these foods are doing, and we change our messaging. You know, people have said, oh, Dr. Perlmutter told us to be on a low-fat diet. Now he's saying that we should eat olive oil and butter and fatty fish. Gosh, how can you believe that guy? Because I change my messaging based upon what the science is telling us. Now, I eat anchovies and I eat sardines, and I'm not a vegetarian, so I do eat fish, and I eat some free-range chicken, and I might have some beef. I enjoy that. But I think we get to nuancing it a bit in terms of quantity. As it relates to meat, really no more than 6 ounces a day, which has kind of been my messaging for an awful long time. And to have a couple of anchovies on your Caesar salad, that's going to be fine. But to be binging on sardines, that's pretty powerful in terms of the purine content. And again, you may get away with it, but that's why you want to home test your uric acid level to see, am I able to have a can of sardines each day? Is it going to be that big of a deal? Might not be.
But if you're drinking fruit juice in the morning and you're having...
You bet. So it's all about cultivating that program that works for you. And it might be that you're on a pretty good program, but your uric acid level is still 6. And that might be when you say, I'll cut back a bit on meat. I'll cut back a bit on the sardines, for example. And certainly alcohol is a big player. But again, this gets back to the personalized medicine. So it's not cut and dry, black and white. It's nuanced. I would be very sad if I couldn't have anchovies anymore, because I really like having anchovies on the Caesar salad. But if I had, my uric acid level runs about 4.5. So I'm feeling okay about that. But if I was running 6.5, the anchovies would go, and I'd be stricter about any alcohol that I consume, for example, and I'd be looking at other sources of uric acid through fructose, through sauces, condiments. I'd be more careful at restaurants, for example.
And to go back to that example, you said you have some anchovies, you have some beef every so often, grass-fed beef, you have some free-range chicken. In the case of those different meats that are there, we talked about anchovies, we talked about beef. What about chicken? Is it all meats that drive uric acid production?
They all do, yes, to some degree. They all contain purines, as do plants. Plants have DNA and RNA, and so they can be a source of purines. And matter of fact, there's certain plants, the cruciferous vegetables, for example, are pretty darn high in purines. If you look at the tables that were given to gout patients over the years, they were told, don't eat broccoli, for example. Don't eat mushrooms. Why? Because they're really high in purines. Well, that's a little bit myopic. It's one thing to say, yes, they're high in purines, but then to make the leap to say, and they're going to raise your uric acid, and you're going to have gout in your toe, that's not fair. Because if you look at what the research has shown in terms of looking at large populations using what are called food frequency questionnaires, those individuals who consume the highest level of those purine-rich vegetables actually have lower levels of uric acid. And we're back to fiber and vitamin C and bioflavonoids that help lower uric acid. So it turns out to be a net gain for an individual to eat those vegetables. So, yet those vegetables have high purines. Dr. Perlmutter didn't say you shouldn't eat broccoli and broccoli sprouts and mushrooms. They're on the list. Eat those foods in abundance.
It kind of reminds me about the whole conversation about salt. There's so many people that are out there that have hypertension, and they're told to, and I know there is a connection with salt and the concentration of salt, and I learned that a lot through, your work and Dr. Richard Johnson's work. But interestingly enough, is that they're told to fear the little bit of sea salt that you might add to a salad or to some roasted vegetables that you end up making, but not understanding that for most people who are eating a processed food diet in America and are struggling with hypertension, high blood pressure, they're getting the vast majority of the salt, not from what they add into foods, but from the processed foods that are out there.
So and the other thing they add is sugar.
Right.
Close to 70% of the processed foods in America have added sweetener. By and large, it comes from something called, who guessed it, high fructose. Don't want that, corn syrup. So this is corn syrup that has, at the minimum, 55% fructose. And why more fructose? Why was that created? That was Dr. Richard O. Marshall in 1957 developed that technology, University of Oklahoma, because it's cheap and fructose is far sweeter than glucose. So the higher level of fructose, the less you need to use to sweeten your food, the better is the profitability, right? So, but let me get back to the meat question, and then we'll talk about salt in just a moment. The biggest issue as it relates to meat are the organ meats. They are really high in purines. That would be eating liver and kidneys and pancreas. I mean, I just never gravitated towards those foods, but they're probably good for you in some regard. I know liver has, B12, etc. But by and large, those are the really high purine foods. And venison and gamey meats as well ostrich have high levels of purines. Now, as it relates to salt, anything over about 11 grams a day then creates a threat through the mechanisms that we've been talking about today. Salt, specifically when it is raised in the bloodstream, activates two enzymes. The first is called fructokinase. And what is fructokinase? That's step one in the metabolism of fructose into uric acid. So we want to limit that. Matter of fact, there are pharmaceutical companies that are now understanding this relationship between fructose and obesity and making body fat, are now creating drugs that will turn off this enzyme fructokinase. Higher levels of sodium in the bloodstream turn on this enzyme. The other thing that higher levels of sodium do, they activate another enzyme called aldose reductase. That'll be on the quiz, so you better remember that. Aldose reductase actually converts your blood sugar or glucose also into fructose, telling your body, winter's coming, make more fat. And every time I say this winter's coming, I keep thinking of Game of Thrones that we're waiting, but it's a different winter.
Going back to the organ meats, this is where I think that the people that are listening naturally, again, we have to understand, and this is why we have to be wary about following anything that's too sensational.
Right.
That one food or one style of eating is the answer or the destruction of humanity. We already know that largely we're already doing that on our own from a human level. 11 million people a year dying from chronic diseases that are directly related to ultra processed and processed foods that are out there. We know that that's the worst thing. And generally, if you're in the category of primarily focusing on whole foods and not drinking sugar, you're in already a good boat, right?
Right.
Now, in the category of organ meats, we've had people on the podcast before, friends, colleagues of both yours and mine, people like Dr. Terry Walls, who have talked about in their protocol, like the Walls protocol, how organ meats, in a targeted fashion, she's not basing the entire portion of her diet around it, have been a central part of what she's seen that has been helpful to people that are on the Walls protocol. So put this in terms of context and quantity. And again, things are evolving and we're all learning together. And your book is a part of that process that you might start seeing a lot more functional medicine doctors and integrative doctors talking about uric acid. I suspect that that's going to be the case. So with organ meats, put that in context with everything else that's out there. If we've heard some of the benefits that are there for organ meats, but we're talking about them being ultra high in purines. Just I want to see how you sit with that.
Well, I spoke with Dr. Walls last week and we talked about diet, as you might expect. And I think her work is absolutely outstanding. There is obviously upsides to eating organ meats. As mentioned, there's some good things going on in organ meats that are good for us, nutritious. But again, this isn't black and white. It's nuanced about, what might the downsides be if we go overboard on it? Now, Dr. Walls likes organ meats because now we're not eating carbs, where it helps a person get more into a ketotic state, which from her perspective is a good thing. It certainly speaks to a Paleolithic sort of approach to eating, which is what her new diet is really focused on. And it might be you can have all the organ meats you want if your uric acid is in the normal range, or the optimal range, as I prefer to say.
So if somebody was eating organ meats, but they're measuring their uric acid and they're in the optimal range of that, that 5 number, and you mentioned for you, you're usually around 4.5, you said?
4.5, 4.6, yeah.
Yeah, 4.5, 4.6. You're okay with it?
Oh, I would say yes. I mean, there are other considerations with respect to eating a lot of meat in general, because you tend not to get fiber into your diet, which is, there's no fiber in meat, and that can be an issue. But, I don't think we're talking about black and whites. We're talking about optimizing. We're talking about yet another lens to look at. That's the beauty of what we call the love diet, lower uric values. The beauty of it is you can be vegetarian. You can be, pure Paleolithic if you like. And you can still make these subtle changes and nuance that dietary approach through the lens of keeping your uric acid level in check. But, to get back to a point you made earlier, what's it going to take? Is this just a functional medicine sort of approach who is going to embrace this? I think not. I think with the level of research going on around the world, there is already traction in the understanding of uric acid. And for your viewers who are going to present this information to their treating physician, there may be some skepticism. And I would say, the simplest thing is ask your treating healthcare provider to do one thing, and that is Google 2 words, metabolic and the word uric. You don't want to Google metabolism and uric, because then you'll get uric acid metabolism. You don't want to look at that. You want to look at metabolic, because then you get metabolic syndrome and all that. Metabolic and uric. And you could look at PubMed. I mean, the number of literature citations is overwhelming. And to be fair, people tend to be down on what they're not up on, meaning that if they have not been exposed to this, I mean, you, after speaking with Dr. Johnson, as you said, went down the rabbit hole. And I'm sure you uncovered incredibly vast resources of information related to this new concept. And the beauty of it is it plays into our understanding of the mismatch between evolution and environment. And we've got to bless this evolution. We've got to praise it for all that it does for us, that it has cultivated this incredible human body that is so resilient and adaptive to some degree. Is it perfectly adaptive? No. To changes in environment? No. But as you mentioned, we are omnivorous. We can tolerate a lot of different types of foods, provided those are foods that we've been exposed to in the past. And I would submit that the crap that we are exposed to now is nothing like the human body has ever had the opportunity to adapt to. And it calls to me back to that article I wrote when I was 16. What about us with this outdated machinery that we're not going to adapt quickly enough to deal with the degree of processing of our foods? The whole notion of the term food manufacturer, I mean, that is an oxymoron. Food isn't manufactured. We don't make food. We can grow food. We can find food. We can cultivate food. But the idea that food comes from a factory and our scientists can outsmart nature and create these things that we then consume, I just don't think that's anything that we can expect is going to happen in our lifetimes.
You recently on social media wrote this, what I would call like a love letter to honey.
Oh, yes. One of the most popular posts ever.
Talk to us about honey, how you used to see it, and how you see it now in the context of everything related to uric acid.
And, my mission is to be as forthright as I possibly can.
I appreciate that about you.
And sometimes...
That's what we should all really step into.
Sometimes it seems to run counter. But yet we talk about it anyway. And it was an Instagram post, and I said, honey, I'm sorry. And then I went on to explain why. And it went crazy because I think people thought I was apologizing to my wife. And so they thought, oh my God, he's going to tell us what he did. And so I have been negative towards honey, dare I say, castigating honey over the years because of its high fructose content. And,
it would be lumped in the boat. Sorry to cut you off. It would often be like sugar is sugar is sugar, and people would kind of put it there, but specifically because it had fructose.
Specifically, honey has high fructose. And it turns out that the research relating honey to metabolic issues and diabetes shows that it's not related to increasing risk and may actually be therapeutic. That's what the literature shows. I kick and scream about that a little bit because it doesn't fit. It doesn't fit at all, but I'm going to be here and report it because that's what the science talks about. It's counter to my intuition, but nonetheless, that's what they've said. And now we have to ask ourselves, why is it, the bioflavonoids? Are there other ingredients, other things that honey contains that make it ultimately salubrious? I don't know. That's obviously what's going on. So I'm going to say that having a little bit of honey in moderation is a good choice. Now, having said that, and even higher and more, and clearly, honey is not generally a processed food, but the processed food that is lumped in with honey is agave. Agave is clearly fairly highly processed, and there's nothing healthful about agave. It's probably the highest fructose source you can consume, and it is there's no redeeming value of agave. Now, I may come on your podcast in a year and a half and say, hey, honey, agave, I'm sorry.
Probably not.
But probably not. There's no redeeming value at this point in time for agave, though it is called nectar. It's nothing, the food of the gods. We need to avoid agave and all other so-called hidden sources of fructose, and there are many.
So on that topic, there are a few other types of sugars that are coming out there that are getting a little bit of traction, and just would love to ask you before we talk about a few other plant compounds and potential therapeutic benefits of some things that can help us bring uric acid down. So allulose is a sugar, is a sugar-like thing. I'm just saying sugar, but it's not actually sugar. As far as I can understand from having looked into it, is that it's a extracted a compound that really comes primarily, it's coming from, they're using corn, as I understand it.
They're using fructose from corn.
They're using fructose from corn.
Can you imagine?
Right, which is scary for a lot of people.
It is scary, and yet, what do we know about allulose? We know that allulose, the research shows that it is beneficial for insulin resistance, that it has positive effects on blood sugar. Generally, my hope is to help people cultivate decreased exposure to sweet taste so that they don't crave it as much. That may never fully undo our desire for sweet, which is hardwired. But if people do need a sweetener, I think allulose is not a bad choice.
Right. It's getting some traction.
There's
some healthier for you candies, other things like that have allulose in them. But I think that this goes back down to some of the science around also just dopamine stimulation. And we don't want to constantly be going throughout the day, having a super sweet latte to a super sweet orange juice to a super sweet, after lunch, snack to another super sweet. And we're constantly spiking our dopamine throughout the day. And we're never able to really sort of appreciate the joy and the beauty that comes from just having, a small bowl of blueberries or an apple or whatever it might be.
Exactly. And again, that is so fundamental to the standard American diet, and that is sweets at every meal.
But I will say this is what I've been doing. Since I've been talking so much about CGMs, a lot of people find that one of the first things that they do starting off their morning that spikes their blood sugar and keeps it going throughout the day, even a lot of healthy people, is they don't realize how much the almond milk that is sweetened that they're having, or many people are like, I don't have sweetened nut milk, I have oat milk.
Right.
And oat milk has a ton of sugar that's included in the manufacturing process.
That's right. So
we've gotten everybody to switch over to, unsweetened almond milk. And sometimes people have that sweet taste in the morning. And I've said, try allulose. So far it seems, and again, you may come back on here next year and tell my audience to maybe potentially avoid it, but it does seem that is I would rather still steer people, if they're going to make a homemade latte, go with unsweetened almond milk or seed milk. And if you want a little bit of a sweet taste, you can add in some allulose or potentially maybe even a little bit of honey.
Perhaps a little honey or, even monk fruit.
Right. Even monk fruit, which I love.
Yeah, I don't.
But all in the context of we need to really be looking at our uric acid levels and see how
that's right. And so just to take apart a little bit, deconstruct what you said, you get up in the morning and you want to have that coffee beverage, whatever it may be. And I think people think that, if they're going to go to the coffee shop, and while there's a lot of research on the upsides of coffee, it, as a matter of fact, lowers uric acid. One new study came out just yesterday showing that coffee drinkers have a significant reduction in risk for Alzheimer's. And having said that, it's not news. We've known that for quite some time. But it doesn't mean that a triple mocha, frappe, latte, whatever that thing is that comes in a great big plastic thing with a container with a straw sticking out, that's not coffee. That's not your morning coffee beverage that we are talking about. We're talking about black coffee. The other thing is, in terms of starting your day, your breakfast, there's a lot of merit to putting that off, the breaking of the fast, the break fast, to putting that off. I guess time-restricted eating would be another topic perhaps for another guest, but the notion of protracting that period of time before which we then consume food, I think there's a lot of merit to that, and even offers an offset for improved metabolism that might be compromised by having a high uric acid. What did I just say? That if you can engage the notion of time-restricted eating, compress the amount of time during which you eat food in a given day to 8 or perhaps even 10 hours, that the upsides for your metabolism might offer an offset to you if, for example, your uric acid might be a little bit elevated. Yet another powerful tool. We actually talk about time-restricted eating in the book.
As we wrap up here, quercetin. Talk about quercetin and some of the reasons that you highlighted that in the book and some of the research that's related to quercetin, which has gotten a lot of attention in the context of COVID-19 and people paying attention to it. How does it relate to uric acid?
Well, you're right that quercetin has been on a lot of people's radar screens for quite some time because of its anti-inflammatory activity, its antioxidant activity. It is a bioflavonoid that's rich in various foods. Probably the richest source in nature would be onions, and in particular, red onions. I've been interested in quercetin more recently because of its senolytic activity or purported senolytic activity. In other words, the ability that quercetin and others similar bioflavonoids have, like fisetin, for example, to help our bodies rid themselves of senescent and perhaps not as fully functioning immune cells. But in the context, and this is really very exciting, of uric acid, quercetin shines. Quercetin is almost or perhaps equally as powerful as the pharmaceutical I mentioned earlier called allopurinol in terms of targeting a specific enzyme called xanthine oxidase, which is fundamental in the production of uric acid. So we are able to limit the production of uric acid by using quercetin. One study of 22 young males with borderline elevation of uric acid done in England demonstrated that 500 milligrams per day in 2 weeks was able to lower their uric acid without any other dietary change in comparison to placebo by 8% in just 2 weeks. That's big time. So quercetin and 500 milligrams a day, luteolin, another bioflavonoid, 100 milligrams per day. Luteolin is the one that is in fact demonstrated to be as efficacious in targeting that xanthine oxidase enzyme and lowering uric acid in comparison to a drug, allopurinol, which is a gout drug. So here you can get things at the health food store that'll lower your uric acid. Of course, we call these supplements, meaning that they are supplemental to the big program, which is, cutting off uric acid production at its source, mainly getting rid of the fructose, the free fructose in your diet, the fructose that's added to your sauces, your condiments. That's, as I mentioned, more than 60 to 70% of packaged foods in America, and even fruit juice. Though we think, oh, I'm getting my vitamin C, I'm going to be healthy. I'll drink a glass of fresh orange juice every day. You want to avoid that. Eat an orange, eat an apple. It will keep the doctor away.
It's powerful information, and it's really just another layer that we can add to the things that we're up to. And for a lot of people, I think it's going to help connect the dots about maybe how some aspects of how they were trying to personalize their diet wasn't maybe working for them because they had liquid form of fructose in their diet as a big driver, or they were maybe focusing on too many high purine foods. And with just a little bit of optimization, we can start dialing these things in. Is there a brand of uric acid meter that you like, something that you recommend, or is it just
I use a brand called Uasure. It's Uasure, and they're available everywhere.
Are they typically like a finger prick sort of?
You bet. And the trick that I've learned I'm not keen on the finger prick. That's why I like CGM. But if you put the little lancet right under your thumbnail, works like a charm, and you don't even feel it.
And how much variability do you see? I mean, obviously you're not eating a lot of fructose that's there, but if you have people that you're guiding or people that you've seen on that journey, how much variability will they see in a day?
And I think that people are going to see a lot of variability, not within the day per se, but day to day. And so it's highly variable based upon levels of physical activity and the amount of fructose consumed. Liquid fructose will right away raise uric acid. I mean, that's not gonna say that's what it's designed to do, but that's how it plays out in your physiology. That's what, that's the signal. You're suddenly eating a bunch of fruit to get ready for winter to make fat. And boy, that mechanism is activated. The alarm system is lit up. The board is all on lights. Winter's coming. We've got to make fat. You shift your entire metabolism. Everybody comes on board. All the little cells in your body are starting to get dialed in that winter's coming. And clearly we need to do everything we can to to turn that off, because there's no need. It just and that's the centerpiece now.
Just as you mentioned, for you, cashews, that was something that you were highlighting. Again, just for you, that you've monitored and you saw.
I love them.
Yeah, though you love them, and I'm sure you have them occasionally, and it might just mean less quantity, right? And being aware. Is there something on a gut health level that you find doesn't work for you? Like sometimes people see that, even though certain types of dairies could be beneficial, right? Like super high quality dairies or goat's milk or sheep's milk. I personally know for me that, dairy, no matter how high the quality, I have to be very careful about the dose, because I still am very reactionary, probably because I was on a lot of antibiotics when I was younger, and, it decimated a little bit of my gut bacteria. When it comes to your gut health, and we're also eating for our gut, are there foods that you just know that don't sit with you as well, if there are any?
I would say that that's more of a cognitive prefrontal choice rather than, more of an emotional or a visceral kind of a response. I don't have any real intolerances that I can experience, or I have experienced, and therefore know that particular food isn't good for me. My choices come from more of an understanding in terms of the value of a particular food, or the threat of a particular food or lifestyle choice or medication, you name it, in terms of the gut bacteria. Give you an example. Last week, I had surgery on my shoulder, and I was given a prescription for an antibiotic, and to keep the wound from being infected, and made sense to me. I mean, my career started off in general surgery, then neurosurgery, and that was standard operating practice. So I know what a threat that you just mentioned it, how your early life experience was. I know what a threat that is. Antibiotics, though they can save lives and are a very important part of our armamentarium, nonetheless, they are weapons of mass microbial destruction in the gut. And I elected not to take it. And so far, so good. I'm 4 days into it. My wound looks just fine. So I think I'm going to be okay. Would there have been an upside to taking an antibiotic in terms of reducing risk of infection? Yeah. I would think, but knowing the downside, knowing the risk, knowing the relationship between antibiotic exposure, for example, and the development of type 2 diabetes, well described. In women, antibiotic exposure is associated with an increased risk of breast cancer. There, we could certainly talk about antibiotics and nonsteroidal anti-inflammatories and acid-blocking medications and a host of others that are directly threatening the gut bacteria. But so I think that, these are choices that I make less on how it feels to me, as opposed to, what I understand about the science, and then taking that information and getting it out in any possible forum, like chatting with you today, that allows me to get information out that, that would be helpful for people in terms of catering to the health and diversity of their gut bacteria. It's really, really important. Matter of fact, interestingly, a study was published this morning that was sent to me by Dr. Stephen Gundry. You may have heard of Dr. Gundry, has done a lot of work on lectins, and a terrific guy, cardiologist. And the study had to do with this very, very primitive tribe that's often studied in Bolivia, where they have what looks to be a very primitive array of bacteria in their gut microbiome. And it looks like their microbiomes, when it's sequenced, emulates what our ancestors from thousands and thousands of years ago had in their gut. And we're actually able to determine that from looking at fossilized poop. We're still able to recover markers that allow us to determine what the bacteria was like. Anyway, the study today said that these people who are infested with all kinds of bacteria, but beyond that, all kinds of worms and other parasites, that they demonstrate larger brains, reduced risk of coronary vascular disease, and really preservation of their bodies as they age in comparison to age-matched individuals living in modern society. So my point is that this relationship we've been talking about since we started today. This relationship between what our gut bacteria are doing and their diversity, is huge and extremely valuable. We're just beginning to understand it and therefore be able to tap into it as another powerful tool in the toolbox. I interviewed a Dr. Molly Fox several years ago, a researcher who in 2013 published a report that correlated Alzheimer's risk with what's called hygiene, basically. And the marker of hygiene was looking at how many parasites were in the gut. Those countries, she looked at 100 countries around the world, those countries around the world that had poor hygiene, as evidenced by higher levels of parasites in the gut, had the very lowest risk of Alzheimer's. Countries with great hygiene, countries in Northern Europe, the United States, et cetera, that are very much invested in hygiene, keeping us sterile, keeping us clean, keeping our kids from playing in the dirt, had the highest levels of Alzheimer's. A correlation, certainly back in 2013, just a correlation, though I've interviewed her more recently. And now that we understand mechanisms whereby the gut bacteria are regulating what we've been talking about, our blood sugar, regulating the set point of inflammation, regulating autoimmunity, I think it becomes extremely valuable information as it relates to the understanding the relationship moving forward and what we can do about it between the gut and the brain.
Yeah, and it really upends a lot of these thoughts that, all parasites are bad. Some of them can help produce additional mucus lining in a positive way in our gut bacteria and have been used, especially studied in places like Israel for treating autoimmune and other type of, food sensitivities. It's a whole new field that, I'm excited to learn more about. But what is the takeaway from those groups? It's not that we want to go and necessarily be unhygienic in our life on purpose and that sort of thing, but we do maybe want to not be worried about the dirt and this especially in coronavirus sort of times. Big review coming out of Harvard's School of Building Sciences. I forgot the exact name, but showing that there's really no documented cases of coronavirus spreading through surfaces, and everybody was completely disinfecting all these surfaces. You go out in the early days, you see all these parents carrying hand sanitizer, putting all around their kids, killing all their good bacteria. How are ways that we can take the findings of that study, that review that Dr. Gundry sends you, and incorporate into our lives, like very practical ways that we can start to practice that in our lives?
I think the first thing would be to recognize what are the choices that we make that threaten our gut bacteria. So we've talked about, for example, medications, drugs that are so capriciously prescribed these days, like antibiotics. When you come in with a sniffle, you're going to need some antibiotics. And beyond that, what's available without a prescription, like the non-steroidal anti-inflammatory drugs, ibuprofen, and the acid-blocking drugs that, Larry the Cable Guy would tell us we should be taking every time we have an upset stomach. There is wonderful research published in the journal Stroke that relates utilization of these acid-blocking drugs to higher risk of stroke and higher risk of Alzheimer's disease by significant numbers. And why might that be? Well, we know that there might be some pH or acidity issues related to changing taking an acid blocking drug. But beyond that, but perhaps related to changing in pH, even a subtle change in pH imparts dramatic changes in the diversity of the bacteria in the gut, favoring some to live, some to die. And, there are gut bacteria that are so important for our health and our survival, our immune function. I had an interesting chat not too long ago, maybe 2 weeks ago, with Dr. Stephanie Seneff at MIT about how glyphosate, which is an herbicide sprayed on so much of our food these days to kill weeds in the field to allow the soybean to grow, and sprayed around our homes, not our home, but other people spray it. And, city sprays it on the sidewalks, parks where children play. Gee, I should stop. But how glyphosate tends to weed out, what a term, tends to favor the overgrowth of so-called bad bacteria and compromises the good bacteria, compromises bacteria that do good things like make B vitamins, that maintain this mucus lining that you referred to a few moments ago, that is so valuable in terms of maintaining the integrity of the gut lining, such that glyphosate exposure then sets the stage for leakiness of the gut, which is absolutely what we don't want if we want to have an adequate function of our immune system and regulate inflammation. So, as a matter of fact, it does matter. It matters a whole heck of a lot. So I think the keys to the kingdom really focus on what do we do to preserve a healthy microbiome? And so it's identifying, well, where are the threats coming from? Threats are coming from these medications, from chlorination in our water, from we can threaten our microbiome based, obviously, upon our food choices, not having enough fiber. Our gut bacteria need fiber that nurtures them. We call that prebiotic fiber. So favoring those foods higher in prebiotic fiber is a good choice. Onions, garlic, leeks, avocado, and these are all sources of good fiber. There are nutritional supplements that can give us good prebiotic fiber that are made from things like the acacia tree or baobab fruit, and others that nurture the gut bacteria. And beyond that, just recognizing that all of our lifestyle choices are seen through the lens of the microbiome, whether we've gotten a restorative night's sleep, whether we are experiencing higher levels of stress. What is that stress hormone? Well, it's cortisol. What is the effect then of cortisol elevation on the gut? Well, it's dramatic. Cortisol favors the overgrowth of certain organisms, including yeasts, that are disruptive to the balance of the gut bacteria and directly threatens the integrity of the gut lining. Then it feeds back on the brain and is somewhat threatening to the neurons, the brain cells in the brain's hippocampus, and therefore, ultimately, it takes away the control over what's called the hypothalamic pituitary adrenal axis and leads to, you guessed it, higher levels of cortisol yet again threatening the gut bacteria. So, it's comprehensive. Take away the bad things, help to put back the good things. But I think the take-home message here is to just embrace the incredible role that these bacteria and other species are playing in the gut in terms of regulating so many important aspects of our lives, whether it's our metabolism, whether it's our mood, whether it's our brain functionality moment to moment, immune system, that's for sure. Even our gene expression to some degree is regulated by some of the products manufactured, like short chain fatty acids, by the very bacteria that live within the gut.
You mentioned, we've talked about how the things that harm the gut and the things that you're mindful of, and you just went through a whole list of toxins, being mindful of antibiotics, etc. How do you think about diversity in the gut? It seems to be, from everything that we're seeing so far, that diversity in our bacteria is strongly linked to diversity in our diet, especially of these polyphenols that you hinted at earlier. So how do you approach your life? In the past, our hunter-gatherer ancestors, they just ate seasonally and what was available. So they had a natural wave of diversity in their grocery store of nature. They would just go out and they would, see things and eat them, and it would change all the time. In our modern world, where we all get caught in habits, how do you approach diversity in your own life?
Let me just break that term down a little bit and then allow me, if you will, to broaden it in its scope. So while we're talking about diversity, the various species that live within the gut, diversity begets resilience. We certainly see it in the Amazon rainforest. The more diverse the flora and fauna, the more resistant the Amazon rainforest is to environmental insult. And so it is with our gut. The more diverse organisms we have, the more we are able to respond to various unforeseen challenges that are certainly part of our day-to-day lives. So diversity makes for resilience, and I think these days that's a comment that I will make in terms of our society, that we need to embrace the diversity of each and every one of us, that everybody has unique skills, unique talent, unique faults, and we certainly look different. Everybody looks different, whether people are taller, smaller, have different skin tones, whatever it may be. The diversity of humanity allows us to be resilient. We should start to embrace that notion. But let's get back to the gut and recognize that, the food, as you mentioned, plays such a role. And what we do, is go for as much in terms of variations in color on the plate as we possibly can. Yellow foods, very few white foods, lots of purple, deep color is good. Orange, of course, is good. So that relates to things like squash and carrots. We just harvested some carrots last night from our garden. And they were the biggest carrots I think I've ever seen. But that said, I think that, again, looking at the foods that are threatening, we've talked about that, but diversity in terms of color is an easy way. So that's really an important goal for us. Most of what I consume and my wife and I consume these days is plant-based. We do eat some animal products, yes. But I think that over the years, we've become more and more plant-based, as organic as possible, which is pretty much close to 100%. Traveling from A to B makes that a challenge, but once we get to B, wherever that may be, doing our very best again to resume an organic diet. We live on a boat for many months out of the year, and so we actually grow some vegetables on the boat, but we have learned ways of getting organic vegetables. And it's a challenge these days. I was thinking, one day I was thinking about my dad, and I was thinking, gosh, for us to get organic vegetables is pretty easy today, and we can go to a market and there's organic vegetables. I wonder how it was when he was young. And then I realized that when he was young, all vegetables were organic. In the 1930s and 1940s, before we started spraying poison on our food, everything was organic, as it has always been until just a blink of an eye. And we have no sense in terms of what these toxins to which we are exposed can do and is doing to us, in terms of even the very simple nuance of how it changes our gut bacteria. We certainly know, again, through the work of Dr. Stephanie Seneff, that there are some obvious and important changes that take place getting back to the gut bacteria, and downstream effects from that may play out as pathology, that may partially explain the increased rates of autoimmune conditions around the world, and certainly seen to correlate with countries that have higher usage of glyphosate, and things like autism. That represents, a bit of an immune issue, and certainly has some play in terms of the changes that are seen in the array of gut bacteria, and perhaps more importantly, as per the work of Dr. Derek McFabe, the products of those bacteria, the ratios of the short-chain fatty acids that are produced, can clearly affect the brain, at least in laboratory research that he's conducted.
So a clarification on just something that you mentioned earlier. You said most of your diet today, yourselves and your wife, is plant-based. And just for the people that are listening that are looking for a little bit more, of an understanding of that, is it that by volume or by calories, right? Just using calories as a traditional sort of marker, is your diet mostly plant-based? And then also sort of a follow-up to that is that did that change comparatively to how you ate, let's say, even 5 years ago?
The truth is, I don't think it's changed that dramatically, let's say, over the past 5 years. Grain Brain, when that came out, people thought that the diet that we were recommending was basically Atkins Redux, that, this is the next go-around of bacon and, all kinds of meat. And it never was. Even then, we were discussing the very important role of plant-based foods in human diet. So I'm not going to tell you that I calorie count. So I would not be able to give you an answer in terms of where most of our calories are coming from. I'd say probably most of our calories are coming from fat. I'd say probably a good 70% of our calories come from fat. The added fat in our diets from things like avocados, olive oil, avocado oil, nuts and seeds. So, I think most of the vegetables that we are consuming are not really adding calories per se. And so, but I've never really been involved in calorie counting, at least not in the past 3 decades, in wondering where the calories are coming from. The notion of calories in versus calories out is the most important metric for weight loss or weight gain. I think that's primitive and obviously has been refuted. I think we have to understand that our foods have huge effects on our metabolism and our signals. Food is information. And higher calorie fructose containing foods, as we just talked about, is informing our bodies that a time of caloric scarcity is coming. Winter is coming. So that's what you tell your body when you consume things like fructose. The amount of meat we consume is minimal. Seafood has actually been reduced, especially those types of seafood that may be high in purines. Purines also increase what we talked about earlier, uric acid. So that would be anchovies, sardines, things like mackerel, smaller fish, scallops. Those will raise, they have high levels of purines. Purines are a degradation product from both DNA and RNA. And those foods that are dense in DNA and RNA tend to have higher levels of purines and will ultimately raise the uric acid level. That is a metabolic signal telling, again, like fructose, that winter's coming. Make fat, become insulin resistant, raise your blood pressure, not what you want. All through the mechanism of uric acid. So, fish, great, but I'm just certainly not eating as much as before. I still eat eggs. I think eggs are a good food. I had a wonderful chat with Dean and Aisha Sherzai, who have a new book out about eating a 30-day plan for Alzheimer's risk reduction. Terrific book and wonderful people. But our dietary recommendations are slightly different. I mean, they're full-on vegan. And I think that is a very healthy approach to living. Certainly from a planetary perspective, makes a lot of sense. But there are some provisos, as there are with any diet. The proviso in that diet would be to keep an eye on trace minerals, things like magnesium, zinc, also vitamin B12, and make sure you have some source of the omega-3 fatty acids. Being full-on keto has its upsides as well, provisos there. Keto people tend to not eat as much dietary fiber because it is a, quote, carbohydrate. And therefore, that is something they would want to consider in terms of supplementing. Paleo, I think, can get away from people thinking that all meat is good. And we don't subscribe to the notion of processed, cured meats being a reasonable choice, a health food, and certainly foods, as mentioned, high in purines through their metabolism into uric acid would be something to keep an eye on. So again, it's not the diet per se, it's the goal. And I think as we move forward, Dhru, to refine the goal, whether it is reducing inflammation or bringing blood sugar under control, where do we want to go? We can get there. There are many roads leading to the place. And feel free to take any road you want. But I think it's important to define what is the goal, what are you trying to achieve, and then work in a way that's comfortable for you. May not work for me, but we want to arrive at the same place.
You share this term uric acid, and also in the beginning of the interview when we were chit-chatting a little bit before we started, you mentioned that you have a new book coming out, and we'll have you back on to talk about all the research that you have. And that book is primarily focused on this component of uric acid. I think that's going to be newer for some of our audience, even if they've heard of it, and more so the implications. Traditionally, especially in the world of functional medicine, primarily because there was some concerns about when it came to seafood and fish, most of the approach was, hey, let's stick to the smaller fishes because they're going to be lower on the food chain. They're going to build up less mercury, less pollutants, and also less plastics in the ocean. And we know microplastics are a big issue. And now you're sharing that you've minimized some of the smaller fishes. I think the term often used was smash fish, sardines, mackerel, anchovies. Sometimes basically the rule of thumb that even Dr. Hyman talks about today, and that's the beauty of nutrition science, is that it's always a discussion, it's always evolving, and it's always about personalizing it for you. Is he would recommend, if it can fit on a pan, it's probably a better option. So give us just refresh us on the uric acid concept and how also we can pay attention to it. Is this something that people need to be testing for inside of their own bodies? And how closely should we be watching it and paying attention to it?
We've known that fructose is a threat and known it for a long time. But, when you ask your healthcare practitioner, well, why is fructose such an issue? Well, just because it is. In other words, we haven't really unpacked the mechanism, and now we have. And we know that one of the important ways that fructose poses a threat is through its ultimate metabolism to uric acid. It's a unique metabolic pathway that is unlike how we use glucose. And so fructose becomes uric acid, as do these purines, these breakdown products from the DNA and RNA contained in the very types of fish that you described. Uric acid is a signal. It is a powerful signal telling us winter's coming. Make and store fat, become insulin resistant, blood pressure goes up because we may not have enough salt to keep our blood pressure elevated, and it helps keep fluid in the body because we may become dehydrated. So we've just begun to understand through the incredible research of a Dr. Richard Johnson at the University of Colorado. He began his work in 1999 looking at uric acid, but it turns out that in the very late 19th century, a Dr. Alexander Haig published a series of monographs and later a book that correlated uric acid to these maladies I've just talked to you about. He added in things like headache. At that time, we were beginning to get an understanding that uric acid was related to gout. These days, people embrace that high uric acid might set the stage for gout or kidney stones. And it is in that context that most of the discussion of uric acid is had. Having said that, however, most people who go to the doctor, let's say for an annual examination, get some blood work done, aside from some of the cool things that you're in touch with in terms of blood testing, the normal standard panel that people get that looks at their liver functions, thyroid, blood count, etc., generally includes a uric acid level. So therefore, you can get a sense as to what your uric acid is by calling up your doctor's office and say, hey, by the way, what was it last year? That said, again, recognize that most healthcare practitioners are only looking at uric acid, again, in the context of gout and kidney stones. But we now understand a powerful relationship between uric acid and all-cause mortality, between uric acid and cardiovascular disease and cardiovascular mortality, in other words, dying from a cardiac event, a strong correlation between uric acid and directly to blood pressure in both adults and even adolescents, and even body weight. We know that one of the mechanisms whereby uric acid does its damage, one of the fundamental mechanisms, is it inhibits the production of something called nitric oxide in the blood vessel. And that has effects in terms of not allowing blood vessels to open up and allow more blood flow to things like the kidney. It also compromises the way insulin is able to get out of the bloodstream and into cells, particularly muscle cells, where insulin works to bring glucose in and help make glycogen. So we're teasing apart some of these important mechanisms of nitric oxide, but it's like taking the cloudiness off the glass, and we're now starting to see this all become revealed. And it's again an interesting story how this increase in uric acid that we as humans have in comparison to other mammals, but we have it and great apes have it, was really selected out as an adaptive mechanism 14 to 18 million years ago during an ice age or period of succession of ice ages that were periods during which our food supply was reduced, allowed us to survive and pass on that new genetic array whereby we don't have uricase, the enzyme to break down uric acid. Therefore, it accumulates in our bodies. So we stay away from fructose. We stay away from high purine foods. We realize that things like quercetin and vitamin C and luteolin, for example, are powerful inhibitors of an enzyme called xanthine oxidase. That is the enzyme that manufactures uric acid in the body and therefore can target. We can use this to target our elevation of uric acid by adding these to the program. Tart cherry extract as well works to inhibit our body's production of uric acid. Very valuable. And we, when you look at research whereby researchers are now using pharmaceuticals like a drug called allopurinol, formerly only looked upon as a gout medicine, but allopurinol, like luteolin, like quercetin, like vitamin C, inhibits that enzyme. It's a drug that inhibits the enzyme that makes uric acid. Researchers are now using allopurinol and finding that when they inhibit the production of uric acid, it leads to lowering of blood pressure. That's profound because it really insinuates this mechanism in terms of being front and center, in terms of what elevates blood pressure, especially in adolescence. So it's very empowering to learn this about uric acid. So yeah, your doctor can check it, easily done. He or she may not embrace the notion of its widespread implications in terms of health, but that's okay. They'll come along. There was a time when you would ask a doctor for a C-reactive protein, they would say, well, why? I want to know my homocysteine level. What in the world is that? And why do you care? Well, because we're reaching a time where the consumer understands why these things matter and is taking things into their own hands. And I think that's a great thing, that you don't have to be a diabetic moving forward to understand, to be able to check your own blood sugar at home. And that's great information, to check your own ketone level at home. We all do that, right? But now we know you can go on Amazon or wherever you want and buy a uric acid kit and check your uric acid levels. Mine last night was 4.4. We want to keep uric acid levels below 5.5 milligrams per deciliter. In other countries, the units are different. The numbers are different. But here in America, it's milligrams per deciliter. That's what you'll get at the doctor's office. It's what you'll get when you buy a kit to measure it at home. So that's empowering, to be able to measure your uric acid level at home and know, do you need to work at it? You need to add a little quercetin, some tart cherry, more vitamin C, maybe some luteolin. Do you want to eat foods higher in luteolin like onions? Do you eat too much fructose? Are you having a high purine diet? All things that are important in this new metric that I think is really going to take hold. I think there was a time when that we've been talking about keto now for a number of years being important. Blood sugar is so important. I think that people like Dr. Richard Johnson have really helped get the word out that uric acid is a player. And it's a player that is on in our toolbox for each of us, whether, mainstream medicine is coming along with that or not. I mean, figure it out. You go to your mainstream doctor and say, I've heard some good things about being on a keto diet. And generally, that's not something he or she is going to embrace. Similarly, we're going to see that happen with the uric acid story, because there's so much research that underlies it these days that's so supportive.
Tell us about a few surprising foods that came across your plate, foods that, like, even maybe one or two that you looked at through a completely different lens after doing the research and the deep dive that you did around this book. And then we'll unpack the whole concept of uric acid, what it is, why it matters, and how you figured it out.
Okay, here are the bullet points.
Yeah.
Beer, sardines, anchovies, and of course, fructose, the sugar fructose uniquely.
So all three of those categories as being foods, because I said surprising, I didn't say whether they were good or bad, quote unquote. And you would say that these are foods that all drive uric acid levels. And that's why if you're eating them or you're consuming any of these foods on a regular basis as part of your diet, you really want to be paying attention to this interview.
That's right. And, for years, there's been this attempt to make us believe that fructose was somehow a safer, better sugar because it doesn't elicit an insulin response. And therefore, hey, it's a great sugar for everybody, and diabetics especially. And the truth of the matter is nothing could be further from the truth. We know that fructose drives metabolic dysfunction, and that metabolic dysfunction is at the core of our most dreaded common diseases of our time: the coronary artery disease, Alzheimer's, cancer, diabetes. So it is, understanding this new biochemistry of the downstream metabolites of fructose, and specifically uric acid, that is a revelation, and it is exceedingly empowering for each and every one of us. This is a new tool in our toolbox like we've never had before, and I just get pumped up to talk about it.
So take us on the uric acid journey. Most people aren't always familiar. They know that sometimes they see it on a test report back from their doctor. There's not much discussion around it. How does the traditional world of medicine look at uric acid? How do you look at it now through the lens of some of the surprising research that's been actually out there for a few years now that you came across? And what does it mean to us as we're thinking about how to optimize our health?
I'd say that you probably wouldn't need to ask me another question for the rest of our time together today, really, because that is, it's why we're here, because we all grew up in the medical field looking at uric acid through the lens of gout and perhaps kidney stones. End of story. And if you went to your doctor and had your blood values done, typically it would contain anywhere between 12 and 20 different parameters. And generally, uric acid would be included through the lens or in the context of gout risk or having kidney stone risk. And now we recognize that uric acid is far from this inert metabolite that might be related to gout, that it is a central player. It's gone from, there's a title actually of a journal article, Uric Acid in Metabolic Syndrome, from Innocent Bystander to Central Player. So we recognize that it is exceedingly active in playing a role for the host of metabolic issues that threaten our health, whether it's high blood pressure, fat deposition, keeping fat locked up, gluconeogenesis, or the creation of blood sugar in your body, insulin resistance, oxidative stress, inflammation, nitric oxide inhibition. All of these mechanisms are now associated with uric acid, and were all good things in the day. That becoming insulin resistant, which we now, every guest on your show who talks about metabolic health will say, we had to do everything we can to not become insulin resistant. I mean, Dr. Hyman's written books on this topic, Dr. Lustig as well, many people, myself included. And yeah, it's true that these days we should do everything we can not to be insulin resistant, but for 99.99% of our time on this planet, being insulin resistant, having blood sugar higher than what we consider normal, was a very powerful survival tactic. And we wouldn't be here today if it weren't for the fact that we humans, by virtue of our thrifty genome, have a real strong predisposition to raise our blood sugars, to make body fat, to increase our blood sugar, to make more blood sugar in our bodies to power the brain, so that we can avoid the two things that threatened our ancestors: starvation and predation. We've always been at risk of not having food, and we've always been at risk for being eaten by something else in the forest, right? Those aren't really risks that we encounter these days. We're not at risk for having another animal come along and eat us anymore. So I think that where we'll take our discussion today is to an incredibly fascinating place, that through the years of our evolution, we had some unique changes in our genome that paved the way for us to be very thrifty as it relates to the calories that we've consumed, that we've always banked calories in the form of fat so that we would have a hedge against starvation. And that's where this elevation of uric acid comes into play. So what we've learned is that between 14 and 17 million years ago, there was a series of mutations in the genes that made an enzyme called uricase that breaks down uric acid. And these genetic mutations turned off the production of this enzyme, so our uric acid levels increased. And now we know what that means. It means that higher levels of uric acid told our bodies that winter was coming, told our bodies make fat, store fat, make more blood sugar, raise the blood pressure, because that's how we would survive when we didn't have food and we didn't have water. So those of our ancestors that had these mutations then would survive when food was scarce, and they passed those genes on to you and to me and to every human walking the planet now, a time when we don't necessarily have food scarcity. And the biggest trigger of all, to lead back to your original question, is the sugar fructose. Fructose becomes available to us in the late summer and in the early fall. Well, when I say us, I mean perhaps our hunter-gatherer forebears and our primate ancestors. We consume fructose. It's metabolized into uric acid, and uric acid tells the body, hey, get ready, winter's coming. Make fat, get ready. Get ready almost for hibernation. That's what animals that hibernate do. They have higher levels briefly of uric acid. They make more body fat. Then they hibernate and they have the calories to sustain themselves. So it's an incredibly interesting story, because ultimately where we go with that is to where we are today, where we experience the consequences of this evolutionary environmental mismatch. So we have this genome, this physiology, this human body that wants to save every calorie, that wants to make fat to hedge against times of caloric scarcity. And yet we're triggering that mechanism to make more fat day in and day out, to the extent that 1/3 of American adults is obese. And that number is going to be 50% by the year 2020, not 2030. We think 2030, that's in the distant future. I know that this is probably evergreen, but I'm going to say, as we have this conversation, it's 8 years from now, 50% of American adults will be classified as not just being overweight, but obese.
You mentioned consequences. Obesity is one of them, and uric acid plays a central role in that. We'll come back to that. Well, what are some of the other consequences, diseases that people might think of that are out there, that they know that people, maybe even loved ones, maybe even themselves, that they're diagnosed with, that have a direct connection all the way back to the upstream elevated levels of uric acid that people are facing?
So the number one cause of death on planet Earth are the chronic degenerative conditions. And those include things like type 2 diabetes, coronary artery disease, Alzheimer's, type cancer, various forms of cancer. So what's killing people across our planet are these chronic degenerative, inflammatory, metabolic diseases. At their core, there is metabolic dysfunction that paves the way. Metabolic dysfunction so that we gain weight, our blood sugars go up, we become insulin resistant, we have higher levels of inflammation in our bodies, a central mechanism for things like Alzheimer's and coronary artery disease. So those are the big threats. Even bad outcome as it relates to COVID infection is seen in people with higher levels of uric acid. So it is front and center leading to this metabolic dysfunction in the day of our caloric consequence, in the days when we didn't know we would have calories or not, we knew or we didn't. These issues would be life-saving. They pave the way for our survival in the context of possibly starving to death. That's not generally where we are today. So people should then understand that we're set up to gain weight. We're set up to make more blood sugar by virtue of this innate mechanism that all humans possess. And that is how we trigger uric acid production that is the danger signal. It tells the body, get ready. And then we should then ask ourselves, well, what are those inroads to elevating uric acid? And it's diet, it's lifestyle. Diet, primarily these days, fructose. Our fructose consumption has dramatically increased over the past century, whereas in the 1920s, we would consume perhaps 15 grams of fructose a day. Now that number's up to 55 grams. That, we're consuming 17 teaspoons of sugar a day, the average American. And that's table sugar, sucrose, which is 50% fructose. And fructose and glucose are totally different molecules. Though their chemical formula is the same, their configuration is totally different, and their metabolism is like night and day. We metabolize glucose by using a hormone called insulin, drives glucose into the cells, creates glycogen, we store it. Fructose has nothing to do with that. Fructose is metabolized into something called uric acid, and the consequences of that are manifold. They are severe, and they represent a central player in our time of metabolic discontent, if you will. When you look around the planet, to get back to your question, these metabolic issues are the number one causes of death, and they are avoidable. And, as I was getting ready for our interview today, I was thinking about some of the questions you might ask, and I realized that we say, in general, that Alzheimer's is not really a genetic disease. About 4 to 5% of Alzheimer's patients have a real strong genetic issue puts them at great risk. We don't say, for example, coronary artery disease or type 2 diabetes are really genetic issues. But through the lens of this genetic change that happened to our ancestors and the mismatch then between what our ancestors and even our hunter-gatherer forebears experienced and the world of today, we still have those genes. So in a very real sense, Alzheimer's and type 2 diabetes and coronary artery disease, because they are metabolic, are 100% genetic. They are the downstream manifestation of this mismatch between our physiology, dictated by our genome, and how we speak to our physiology based upon our lifestyle choices, primarily the food we eat, but also the sleep that we get or don't get, the exercise, the stress, the other lifestyle factors that are truly influential in relating to what our genome expects.
Yeah, it's so profound when you zoom out and you think about it. It's like this mutation, as you've been talking about, this genetic mutation that we had, and the people that didn't have it, they didn't make it. So we're all ancestors from those people. And from my understanding, because it's 15 million years ago, it was apes. It was before Homo sapiens, right?
Long before, yes.
Long before Homo sapiens. And so these ape ancestors, there was a group of ape ancestors that didn't have this mutation. They couldn't survive winter. There wasn't enough fruit trees that they had access to. They couldn't store fat. They couldn't do our evolved ape ancestor version of making it through the winter instead of like a full-blown hibernation, right? Because at that point in time, there wasn't really a full-blown hibernation period that our ape ancestors were going through. And now, because our modern lifestyle has changed so much around us and there's so much fructose in our environment, we'll talk about the top sources that are out there. Surprisingly, some foods that many people think are healthy that they're eating on a regular basis that could be driving these higher uric acid levels. But because we're so much surrounded by it, we've changed and our environment has changed, but our genes have not changed. And that's why we're in this mess that we're in today when it comes to chronic disease.
That's right. And so it's an environmental pressure. Evolution is the response to environmental pressures of one sort or another. And our genome basically is selected for those mutations that will then confer certain superpowers, if you will. And, that this specific uricase set of mutations took place over a couple of million years. So it didn't happen very quickly. And in fact, the changes during the Middle Miocene period were actually very slow with the earth cooling and the progressive loss of food availability. Now, we've turned the tables on these genetic mutations in a century or two, and we cannot adapt. And I actually wrote my first article on this topic a half a century ago when I was 16. I published an article in the Miami Herald talking about, what's happening to us who are, in my words, stuck with this outdated machinery. So we can't evolve quickly enough to be able to be in concert with our current environment. We can't change our genome. We don't have that technology just yet. Maybe we will, but we can sure change our environment. This is sort of the underpinning of the so-called paleo movement to try to emulate the environment of our ancestors that coexisted quite well when you looked at the relationship between genome and environment. Now there's a great disparity between those two. We want to try to do what we can to give back to our genome those signals so that it can keep us alive. Those salubrious signals that we give via our foods, the environmental choices that we make. And that's what this is all about. And focusing in on uric acid as being that sentinel, that alarm signal. And we want to do everything we can not to trigger it. You know, there's a really powerful study from 2016 that looked at 42,000 men and 48,000 women, a big study. And they showed that those in the group, they followed these people over 8 years, those in the group who had the highest level of uric acid had about a 16% increased risk of what is called all-cause mortality. What does that mean? Dying from absolutely anything, from being hit by a bus to coronary artery disease, having a stroke, you name it. But more specifically, those their risk for cardiovascular death in the group with the highest uric acid was increased by 39%, almost 40%. Risk of dying of a stroke increased by 35%. And for every point of elevation of the uric acid above 7, the units we use here are milligrams per deciliter. For every point, so at 8 and then at 9, there's an additional 8 to 13% increased risk of death from any cause whatsoever. And the final conclusion of that study was that in this group of 90,000 adults, that a quarter of the diabetes, type 2 diabetes, had its origin in elevated uric acid. So we have to take this really seriously, but it's good news.
Take us a little bit on the background journey, you write about in the book, about how you went down the rabbit hole of uric acid. And there's a researcher that I'll let you get a chance to talk about, but you were out there running one day listening to a podcast. And as you tell about how you came across this work, which led you to writing this book, and a new friendship that was in your life with this researcher, also help us understand how his work, what gaps in your what pieces of the puzzle that added into your view that functional medicine and your own research has given you when it comes to looking at health and disease?
So my core interest is brain health, and we now fully grasp that metabolic disturbances underlie the most worrisome of brain degenerative conditions like Alzheimer's. I've talked about it before on your podcast. It's that inflammation and insulin dysregulation and blood sugar elevation and obesity are all factors that are deeply involved in setting the stage for senile dementia of the Alzheimer's type, a disease for which there is no medical treatment, no pharmaceutical treatment. So I'm deeply focused on what are the causes of dysregulated metabolism. I'm running one day, listening to a podcast where Peter Attia is interviewing a Dr. Richard Johnson. And I'm starting to get into early on in my run, I'm sort of concentrating on regulating my heart rate and, getting to that magic pace where I feel comfortable. But I suddenly lost myself in this podcast where Dr. Johnson is revealing this central role of uric acid. So I couldn't get enough of it. So I finally get to my last half mile where I pick up the pace and sprint sort of towards my mailbox in front of my house. I get there and I said, I can't stop. I got to keep going. So added on another couple of miles just to hear the end of the podcast. And then went home and did something I don't think I've ever done before. I listened to it again. And it provided me a revelationary tool for controlling metabolism. That here was something I had no knowledge of that made perfect sense from incredibly a large number of perspectives, not just the historical perspective, but the application, the interventional trials that have been done, the retrospective studies that have been done, the epidemiology showing relationships, that I was so taken by this information that I did what you would expect, picked up the phone and called Dr. Richard Johnson. And we set up a time to get together. And I saw the guitar in the background. We were Zooming. And that was it. When I saw the guitar in the background of the Zoom call, I said, I got a new friend. And we just had such a great time together. And I've learned so much from him. I'm thinking he might have learned a little bit from me. I don't know. But I've learned a lot about this gentleman who really has done, he deserves the entire credit for, in my opinion, for revealing this role of uric acid and in our dysregulated metabolism around the world. And he's got 2 decades of research under his belt. He's very humble. And I was very taken when he wrote me and asked if I would write the foreword to his book, which I did. And I actually dedicated this book, Drop Acid, to him, to honor him, just for the work that he's done. This is empowering information beyond measure. This is a tool in our toolbox we have never had, but I think moving forward, it is going to really lead to a lot of improvement in people's metabolic health.
We've talked so much about blood sugar, and of course, uric acid is directly connected to, the blood sugar, metabolic health, as you've talked about a little bit earlier. And the interesting thing that, as I started to go down the rabbit hole of uric acid, which is always included in my blood work, but like a lot of laboratory markers that are out there, they're based on the sort of normal reference ranges for the population. And normal is most of the population is not healthy, is not in optimal health. So what your doctor tells you is normal is not always what is optimal from your stance and viewpoint, and in functional medicine and the latest research. So talk to us about uric acid levels, because it's very interesting. There are a few ways that people can test it, some things that you've talked about on online, and then they can also ask about it from their doctor, but how to interpret it is not always there. So the data is accessible, and it's nice that it's usually a pretty cheap test, but people don't often know what it means, and their doctors aren't often trained in the subject.
True, that is an incredibly important point, because most doctors are going to tell you that, again, your uric acid level is part of your annual blood test as a risk factor for gout. And as such, the norms that have been developed are way too high, because they deal with levels above which then you have a risk for having gout or having perhaps kidney stones. And the level of 7 or above being considered abnormal relates to, again, risk for gout. And also above 7, that's when uric acid has a much higher tendency to crystallize and to form these gout crystals that can be painful in your toe, etc. So if you have an elevated level of uric acid above 7, and you don't have gout and you don't have kidney stones, you have what is called asymptomatic, meaning no symptoms, hyper, meaning elevated uricemia. So asymptomatic hyperuricemia, elevated blood uric acid without having symptoms, is looked upon as being nothing much to worry about. But again, that is only through the context of, or through the lens rather, of gout and kidney stones. So asymptomatic hyperuricemia is a powerful risk factor for elevated blood sugar, for elevated blood pressure, for weight gain. There are a variety of studies that demonstrate that. So it's anything but benign. It's anything but asymptomatic, because you just haven't looked at it. You haven't looked at, how it relates to these other issues. So cardiovascular risk, for example, begins at a level of 5.5 and above. So we really need to revise these norms. And in fact, there are several studies that have had that in their title, that we need to revise what are considered the normative values for uric acid. And I think you make a very good point as it relates to functional medicine, and that is that oftentimes we're not so entrenched in the notion of the so-called normal value that we're really trying to articulate what is the optimal value. The people, normal is what's common. And what's common today is pretty crappy health. And therefore, people who want to be healthy shouldn't look to being normal. I mean, as I mentioned earlier, in 8 years, the normal American will be obese if you consider what's common. And that's not what we want. That's not ideal for anyone's health. So what we're trying to voice is what is optimal and keeping your uric acid level at 5.5 or even substantially lower. And as you mentioned, that's a test most people have had at their doctor's office. And the good news is you can go online and buy your own uric acid monitor. I did. And check your uric acid level with a finger stick, just as you might check your blood sugar level. And I will tell you, sneak preview here, that we may very well see continuous uric acid level monitoring in the future, much as we see CGM, continuous glucose monitoring, now becoming exceedingly popular for exactly the same reason, so we can get a dynamic understanding, a motion picture as opposed to looking at a still photo of what our uric acid level is doing day to day, hour to hour, based upon the foods we eat, the sleep we get or don't get, the level of exercise that we engage. Are we in ketosis? How did that affect my uric acid level? And to understand how all of these inputs have an output that you are measuring on the uric acid meter, I think is really quite profound in your effort to keep your uric acid level under control.
So we know through these examples, and if anybody has had a family member that's had a kidney stone or has been diagnosed with gout, that crystallization, right, is often, people have a picture of it or your doctor talks to you about it, that this crystallization is causing a problem, this uric acid buildup that's over here, and now you have the end result, which is like a kidney stone. In the case of heart disease, what's the mechanism of uric acid being elevated and then contributing to heart disease being more likely in an individual? What's the pathway? What does it make happen more? What does it prevent from happening? It'd be good to tease that out a little bit.
Sure. And we can tease it out for heart disease, but let me just say that what I'm about to describe to you are the same fundamental mechanisms that relate to Alzheimer's, that relate to virtually all of the chronic degenerative conditions that are underpinned by the mechanisms of inflammation, insulin resistance, elevated blood sugar, and all the things that feed into that, like overweight and obesity and the inflammation that causes. So we can have the discussion focused on, again, on heart disease and then simple narrowing of the coronary arteries. But again, those fundamental mechanisms brought on by uric acid are at play across the spectrum of these really pernicious and global issues that threaten our health. So what is uric acid doing? Well, fructose, as mentioned, is metabolized into uric acid. And that is what we call a feed-forward process. The more uric acid is produced, the more fructose is metabolized, because it is a survival mechanism. We want more metabolism of fructose to take full advantage of, to make body fat, to raise our blood sugar. Fructose in the liver turns on this process of gluconeogenesis, the production of glucose de novo. Why is that important? It's important because it provides blood sugar to power the brain, which is kind of like our ace in the hole. We're not the strongest animal, we're not the fastest, but we have a big brain that should keep us out of trouble. We could certainly argue that point these days. We don't know what's going on with our big brain, but it's been a survival mechanism for us to keep our brains online. The consequence, however, is that this raising of our blood sugar leads to the pancreas having to work overtime, insulin levels being higher and higher, to the extent that ultimately we develop what's called insulin resistance, and we compromise blood supply to our vital organs. Another important mechanism relating specifically uric acid to coronary artery disease, but also to brain-related disease, is that it inhibits a chemical called nitric oxide. We desperately need nitric oxide to perform two tasks in our body. Number one, it allows blood vessels to relax, so that improves blood supply to the heart, to the liver, to the kidneys, and to the brain. When the blood supply is compromised, we have things like heart attacks and strokes and problems with kidney function, for example. So that's job number one. We need nitric oxide. Uric acid inhibits it. Number two, lesser known, is the role of nitric oxide in allowing insulin to do its job. So higher levels of uric acid increase the compromise of the ability of insulin to do its work. So this higher level of uric acid, less nitric oxide, we become even more insulin resistant. We starve our organs. And, ultimately, with these higher levels of insulin that have to be produced, that in addition augments inflammation. Inflammation, is another feed-forward cycle because that antagonizes insulin functionality as well. So these, and there's several more. Free radical mediated stress is dramatically increased by uric acid. What I'm saying is the increased production of free radicals. We all think that the more antioxidants that we take, the better, because we're limiting this oxidative stress. Oxidative stress is dramatically increased by the presence of uric acid. The other thing that is going on is that because of uric acid's role in enhancing the activity of a specific enzyme called fructokinase, which is important for fructose metabolism. As mentioned, again, unlike glucose metabolism, fructose metabolism keeps getting more and more with time because we know winter's coming. It's a built-in mechanism that makes all those downstream effects happen more aggressively. The production of fat, the storage, the locking away of fat, the production of higher levels of blood sugar. And one other thing I'll mention is in that process of metabolizing this sugar fructose from, in our ancestors at least, fruit, we'll talk about how we get it today, something very fundamental happens, and it is an energy-consuming process. ATP, adenosine triphosphate, not to be too technical, but that's our energy currency. The three phosphates, when each of them is liberated or taken off of adenosine, it liberates energy. It's the currency of energy in our bodies. So to metabolize fructose, we break down ATP ultimately into AMP, adenosine monophosphate. And without getting too much into the weeds here, that drop in energy is fundamental because it shifts metabolism away from burning energy to storing energy. And to be technical about it, for some of the listeners who like that kind of stuff, it shifts us away from stimulating something called AMP kinase, we'll talk about why that's a good thing, to something called AMP deaminase, or the metabolism of hibernation. It's basically saying, make fat, store fat, become insulin resistant, because this is what you need if you're going to hibernate, or we're not going to have food around. Whereas we want to stimulate AMP kinase because AMP kinase says, hey, let's burn our fat. Let's be a fat burning machine. Let's not store fat anymore. Let's not make more blood sugar because we don't need any more. So what I'm saying is we need to do everything we possibly can to keep this AMP kinase active. And we do so, for example, one of the most powerful things we can do to keep that pathway going. It's a switch. Do you want to make fat, store fat, or do you want to burn fat and not make fat? The most powerful thing that we can do to keep that AMP kinase active are things like exercise and staying away from fructose. Those are keys. We have medicines that activate AMP kinase to turn down our liver's production of blood sugar, gluconeogenesis, glucose, like metformin, for example. That's how that diabetes drug works, by AMP kinase stimulation. You could do it, same thing, by exercising. You could take berberine as a nutritional supplement, for example. But that is the side of that switch that we need to keep active. The other side of the switch is this AMP deaminase that sets you up for making so much fat that you're now ready to hibernate for 6 months. And I would simply ask anyone, is that your plan? Are you getting ready to hibernate for 6 months? Most people are going to say no. And maybe some are, you're going to hibernate in front of a TV and be a couch potato for the next 6 months. If that's the case and you're not going to eat, then you need to make fat. But we're just beginning to unravel this science in the context of what it took for us to survive as long as we've been walking this planet, and our primate ancestors too. This incredible survival mechanism that's been in place for 14 to 17 million years, when we finally look at all of these mechanisms contextually, we realize that that's the problem that we have today. It gets back to this evolutionary environmental mismatch. And I want to give you one more because I think it's really fascinating. Unlike most other animals, and mammals included, we humans don't make vitamin C. I mean, you know that. We don't make vitamin C, so we have to eat fruit. We have to take vitamin C or we'll get scurvy. Our teeth will fall out and our children will be born naked. All the things that happen, right? So we need ascorbic acid or ascorbic acid against scurvy. And, you would say to yourself, okay, that's cool. It sucks to be human because we don't have vitamin C. Let's move on. But why? Why is it somehow an advantage? How did we get selected for to have this last step in vitamin C manufacturing in our body be compromised? There are 4 steps. The very last step in making vitamin C from, oddly enough, glucose is compromised in humans. Well, we have to ask, why would that be a good thing? Because if it were not a good thing, that wouldn't be a genetic issue that we have, right? We would have selected against it, but yet we selected for it. Well, what is vitamin C? It's a lot of things, but it's an antioxidant. And it turns out that, like uric acid, how uric acid induces our mitochondria to pave the way for fat production is through oxidative stress. That's one of the hallmarks of elevated uric acid. Induces oxidative stress in the mitochondria. That is a signal to make fat. If you don't have enough antioxidant, same thing. So that begins to let us understand why it's a powerful positive selection that we don't have the ability to make vitamin C, because this oxidative stress helps us make fat and survive. Not what we need today. In fact, there are certainly some animal studies and some preliminary human studies indicating that higher levels of vitamin C help us reduce our fat production. So I think where we're going today and what we're encompassing is looking at all of these metabolic nuances of being a human being through the lens of the evolutionary advantage that they offered, and now how disadvantageous they are in light of our current environment, meaning our food choices, our other lifestyle choices.
You wrote a really interesting Instagram post, I think it was a few weeks ago, and you were saying Alzheimer's reversal is real. It's not just a theory. And you were hinting at a new study, a small one, but something exciting that came across your desk that you wanted to highlight and make your audience aware of. So why were you excited about the study, and what did they cover inside of there?
Well, I'm hoping you'll share that study with a link. This is work that I've been aware of actually for quite some time. I know you know Dr. Dale Bredesen, and he recently published a book called The End of Alzheimer's, The Plan. The first book was The End of Alzheimer's. This one is The Plan. And I wrote the foreword to that book. And in that foreword, I think it really did capture my excitement about the work that he's doing, even beyond how he's broken the mold beyond Alzheimer's. And let me explain. We live in a world where we try to really pigeonhole our diseases to think that they are caused by one thing and therefore we can fix them with a remedy. And there's such an effort underway to find an Alzheimer's drug that works. Just last month, Eli Lilly announced the results of a trial in which their monoclonal antibody donanemab was found to reduce the rate of decline of Alzheimer's patients by an astounding 32%. When they made that announcement, the stock value went up, I think, $20 billion, Eli Lilly. But what does that mean? It means it slowed the decline by a third. It means people are still declining and going to get worse, and we know where it ends up generally. So it really wasn't stabilizing Alzheimer's, or can you imagine actually improving their situation? Because they're looking at one thing. This is a monoclonal antibody that is targeting this so-called beta amyloid protein that's absolutely the cause of Alzheimer's. Well, we know that study after study has really made it very clear that beta amyloid is almost an innocent bystander. It is the brain's response to various challenges like infections, for example. So it's sort of like blaming the firemen who arrive on the scene for the fire. It isn't that way at all. And study after study where beta amyloid is targeted have actually been shown to make patients decline more readily. So what Dr. Bredesen is leveraging beyond his results, I'll talk to you about them in just a moment. He's really leveraging the notion of multiple inputs, really kind of the cornerstone of what is called functional medicine, where we don't look at what the disease is that a person has, but rather who is the person who has the disease? What is the unique personalized approach that we can take to understand how that person got that way? Alzheimer's is not just a bioenergetic issue of glucose, lack of glucose utilization in the brain. It's not just that there's beta amyloid, not just that there's a decline in acetylcholine, not just that there's temporoparietal atrophy. There are a lot of things that, roads that lead to Rome here, or as I've been said in the past, many places to jump on the bus. And I think that if you're going to ever have a shot at reversing Alzheimer's, you have to understand which of the multitude of factors, and Dr. Bredesen has identified more than 36, not just beta amyloid accumulation or type 3 diabetes or underlying herpes infection. Many things have been proposed. But to try to identify in that person who's sitting in your office with declining cognitive function, what's going on with him or her. And then when you figure that part out, then you develop a program that looks at those issues and does its best to correct those issues. Maybe it's lack of supportive hormones. Maybe it's lack of adequate insulin function. So many different things. Cultivate a program that is specific for that patient. Again, we call that personalized medicine, and realize that can offer up more likelihood of improving that person's situation. So what Dr. Bredesen just published in the study that your viewers can now review is that in a group of individuals who were indeed suffering from mild cognitive impairment or even diagnosed with Alzheimer's disease, that when he created this program and people stayed on a personalized program for the 9-month period of time, that 80% of them didn't just stabilize their condition, they improved. He describes patients going back to work, regaining control over their finances. I mean, it's astounding. And, beyond, if that weren't enough, and it is, believe me, it is in my lifetime to see that happen. But if that weren't enough, the idea that he proposes that we should engage this notion of really gaining as much information as we can about an individual and his or her uniqueness prior to initiating therapy, I think we can use that approach, in all walks of medicine. And to be sure, that challenges the mainstream notion of trying to make people fit into the treatment. I often say that person comes to your office and says, I've been walking 5 miles a day and look at my feet. They're all blistered and torn up. And the doctor says, well, let me write you a prescription for a pair of shoes. And the person gets the prescription filled and they don't fit. It's a size 9 and the man wears a size 11. He comes back and he's complaining. And the doctor says, well, in a study of 10,000 people, size 9 was the average shoe size. So you're going to have to just figure it out. It's very clear that we have to understand the needs of the patients as it relates, in this case, to Alzheimer's disease. There are nutritional issues. There are, a host of lifestyle issues that we've been talking about for years. You and I have had this conversation for a long time that are so incredibly relevant. But yet, the fallback is, well, I'll do what I want, live my life however, and they'll develop a drug one of these days that'll pull me out of the woods. That isn't reality.
You mentioned these multitude of different pillars that could be contributing. It's not one thing, so the solution is not going to be one thing. Let's talk about those items that contribute to it. You mentioned Dale Bredesen. We've had him on the podcast before. We've gone into his books a little bit, but high level from what you've seen and kind of leveraging on some of his work, diet gets so much attention, and we'll come back to diet in a minute, because that's one of the main components that you're super known for with your books that you've put out there, because it's something that we can control. Give us the next big bucket that you often see for people that often doesn't get as much attention as diet does when it comes to cognitive decline, dementia, and Alzheimer's.
I'd say that first, as a counter to the notion of what are the big legs that support this decline, would be genetics. Genetics is not that relevant. In fact, playing only about 5% role. That people say, well, I carry the APOE4 allele, therefore I'm at greater risk. But understand that that so-called Alzheimer's gene plays upon other variables that we can absolutely control. So, the point I want to make for your viewers is really quite simple. And that is, if mom or dad had Alzheimer's, or if you know that you, by virtue of your 23andMe or other genetic profile, carry one or two of what are called the APOE4 alleles, which are indeed associated with increased risk for Alzheimer's, all well and good and interesting. No question that having that genetic predisposition and others, presenilin 1, for example, increase your risk. But by all means, the die isn't cast. It means that our choices, we have control over things that are really influential. And I think the biggest issue would be, and they're all important, don't get me wrong, but I think the biggest issue, at least in our modern world, has to do with our metabolism and elevation of our blood sugar, and therefore compromise of our ability to have insulin in the body do its job. And I think, to take a step back to high school biology, well, what's the importance of insulin? Insulin is important for getting glucose or sugar into the cell, and therefore lowering or regulating blood sugar levels. Well, all well and good, but I think that we have a tendency to be really myopic when we assign our understanding of insulin or other things in the body, other metrics, to a specific area to the exclusion of other functionality. And, for example, we say, well, testosterone is the male hormone. Women need testosterone, very important. Progesterone was named because it's pro-gestation. It's a female hormone that goes up during gestation. Why would my body have progesterone receptors? So I think it's important to expand, in this case, on what insulin does in the human body, and specifically vis-a-vis our conversation now. How does insulin relate to the brain? Well, insulin does play a role in allowing brain energetics. We'll come back to that in a moment, but it's the way that blood sugar gets into the brain, glucose, to ultimately lead to the powering of the brain cells, the neurons specifically. And that's really important. When our bodies become insulin resistant, we'll talk about how we get there. I guess I'm paving the way for a lot of conversation. Then that functionality, brain energetics, is compromised. That's a bad thing. We can scan brains 20 years ahead of time and determine already when there is compromised brain energetics that is the harbinger for future cognitive decline and ultimately Alzheimer's disease. And that means, tangentially, that the choices we make in our 30s, 40s, and 50s are very relevant, because they again portend cognitive decline and full-blown Alzheimer's disease. Other things, however, that insulin does, I think, are very important. For example, we know that insulin is degraded in the brain by something called, oddly enough, insulin degrading enzyme. Well, it turns out that when we're unable to stimulate adequately this insulin degrading enzyme because insulin functionality is compromised, that same enzyme is involved in the degradation of this protein we referred to earlier called beta amyloid. So that's now a connection between insulin and beta amyloid. We know that insulin is important for, again, regulating blood sugar. And why is that important? Because when our blood sugar is elevated, we change our proteins via something called this process of glycosylation, where proteins bind to sugar. And that's an issue, because not only does it change what the proteins look like in terms of their three-dimensionality, but it also, because of those changes, alerts the immune system that, hey, here's a protein I've never seen before. And what happens? the immune system gets activated and inflammation gets turned on. And inflammation is really a central player in what degrades the brain in Alzheimer's. So the point I'm making then is regulation, balancing our blood sugar, keeping our blood sugar under control is, while everything is important, I think that might well be perhaps the most important issue, in terms of what throws the widest net, in terms of, for your viewers, what they need to pay attention to, that this blood sugar regulation is in the front row, and that we need to do everything we can, getting back to diet. And I know you wanted to move past that, but I chose not to, because it's so important, something we all make choices about every single day, unless we're fasting, of course. And everything we can with reference to diet to keep blood sugar levels under control, basically lower than they might otherwise be these days, I think is very relevant. Utilizing things like continuous glucose monitoring, checking our blood for ketones, being really aware of fructose in the diet. So many things that influence blood sugar, our sleep patterns, our exercise patterns, sleep as we measure with our wearable devices. All of these things play into balancing blood sugar levels, and the brain is exquisitely sensitive to its provision of its fuel, which is basically glucose. And when that's compromised, when that is threatened, that really does set the stage for future decline.
I'm glad that you doubled down on the diet. I did want to cover diet. I was going to cover a few other things, but I'm glad you actually forced it in the direction that you wanted to go in, because it's just another reminder that, just like we say, you can't exercise your way out of a bad diet. If you're serious about brain health, you cannot approach the topic without thinking about blood sugar regulation. And I think that's an important message for our listeners. And it's a hopeful one, because that's actually something that's largely in most people's control and will continue to be in their control as they start to use wearables like CGMs. And I know you're affiliated, and I'm affiliated with a company that's doing some great stuff in that space. We'll chat about them a little later on. So I'm glad you doubled down, because I think that is just an important thing for everybody to remember, is that we're looking for sometimes the right supplement. In the traditional world of medicine, it might be actually what medicines are there that you covered earlier, but it really has to come back to core blood sugar regulation. While we're on that topic, you're not just talking about sugar and high levels of sugar in the diet or in added sugar in the foods that are there. Even for people that consider themselves quite healthy, there's other forms of things that are regularly part of our lifestyle today, even in the world of modern wellness food, that are consistently throwing off our ability to regulate our blood sugar. What were some of the surprising things that you found over the years in putting your books together that act the same as sugar inside the body?
Well, that act the same as sugar in the body. Let me just take that back a little bit. And one of the
Please.
surprising things that I found that really plays such a central role in blood glucose regulation is a different sugar called fructose. The amount of fructose we are consuming now is I think, breathtaking, seeing that table sugar is 50% glucose and 50% fructose. That's what sucrose or table sugar is. But now we're seeing our foods peppered, wrong term, sweetened with what is called high fructose corn syrup, which might be 52% fructose, but in reality may be as high as 90% fructose. Now, the messaging on fructose over the years was, hey, that's a better choice than eating glucose, because fructose, unlike glucose, does not elicit this insulin response that we just spoke about. And while that may be true in the short term, we know that ultimately, through its unique metabolism, that fructose is extremely threatening to the way that insulin works in the body, and ultimately leads to elevation of our blood sugar, elevation of our blood pressure, dysregulation of our lipids, increased risk of obesity, increased risk of other metabolic issues. So, we've been told that fructose is a safer sugar. Even the American Diabetes Association did, until quite recently, recommended fructose as an alternative to glucose or highly refined carbohydrates in general. So I think we now understand, and we'll get to this later, that through its production of something called uric acid, that fructose is a powerful threat for our metabolism, and therefore elevation of blood sugar, and then this increased risk of insulin resistance that we talked about just a moment ago. But I think that we could take this conversation to a lot of places. We can take it to the gut bacteria, because we know that the signals sent out by our gut bacteria have a huge role to play in regulating our metabolism. There is well-described changes that can occur in the gut bacteria that pave the way for insulin resistance. And in fact, we know that that is a direct response to the various foods that we eat. But I think, interestingly, we can look at how these changes in our gut bacteria, brought on by, for example, consumption of fructose, and therefore leading to higher levels of insulin and blood sugar, may have been, in our hunter-gatherer days, quite adaptive. Because think about it. When did we eat fructose? When did we have fruit sugar? We had it when the fruit was ripe. And, before modern agriculture, fruit is ripe in the late summer, early fall, signaling to us that winter is coming. Winter, a time of caloric scarcity. So fructose changes our gut bacteria such that it prepares us for winter, because our gut bacteria get the fructose signal and say, hey, winter is coming. We need to change metabolism here and start storing fat and reduce the burning of fat so that we keep it around. And we actually have to make more glucose, a process called gluconeogenesis. So it's the response that we get from fructose, not only in terms of our gut bacteria, but also in terms of what has created the downstream metabolism of fructose, which is uric acid. Uric acid is the danger signal saying winter's coming, not going to be a lot of food. You'd better make fat. You better store fat because you're going to need it if you're going to survive. And we have higher levels of uric acid because of a unique series of mutations that occurred in our primate ancestors 14 to 18 million years ago, whereby we have much higher levels of uric acid. So those ancestors in our primate lineage who had those mutations survived. And now you and I and every other human walking the planet has an increased production of this uric acid, such that we make fat, we store fat, our blood pressure is at risk for being higher. We develop non-alcoholic fatty liver disease, and we develop dyslipidemia, higher levels of LDL and cholesterol, because these were actually protective of us in the day. So what I'm describing then is what is called an evolutionary environmental mismatch, where in our past, these mutations, these changes to our metabolism allowed our survival. But now, because of the different environment being pounded by fructose day in and day out, lack of restorative sleep, lack of enough exercise, we'll talk about these things, challenges our genome. And it's really, I think, the fundamental of the so-called paleo movement, that we really need to respect our Paleolithic genome and give it the signals that we can control that it wants in order to keep us healthy and allow us to survive, allow us to procreate, and allow us to be disease resistant.
It's such an important point, because so many times when people, whether they're in the wellness world or they're just, somebody who's just trying to live their best life, this is not an area they study. They may not be listening to this podcast. Anybody who's dealing with extra fat on their body and has struggled with it for a while feels that their body is working against them. They feel that there's something wrong with them. They feel like, even some cases, I've heard people go to an extreme and feel like their body is almost punishing them. And what you're really highlighting here is that your body is doing exactly what it was designed to do. It's just we're giving it the wrong signals. It's constantly preparing for winter based on the way that we're eating, living, and going about our modern lives. It reminds me of a story that I was hiking up in Glacier National Park up in Montana nearby the border of Canada. And I was with a guide, and she was like, there's this really cool edible berry that I want to show you. And it was about end of September, getting ready for snow season, October up there, especially at higher elevation. And she said, let's go through this path over here. We went to that path, and the berry bushes were there, but all the berries were gone. She's like, oh, the bears actually came in and must have eaten all the berries. They're getting ready for hibernation. So they're eating as much fruit as possible because they're going to go hibernate over the winter. And so they need to store all that fat. And so in that same way, we're going around in our diet between the grains that we're eating, the fructose that's in our diet, the severe blood sugar dysregulation, the overproduction of insulin. We are telling our body winter is coming and we better get ready. One of the things that I'm sure you've seen this too with a lot of people that follow your book, blood sugar. If we look back actually and zoom out at sort of dietary trends in America, starting first with sort of Alice Waters, the sort of farm to table movement, the rise of sort of vegetarianism in the 60s with sort of the hippie culture and that sort of thing like that. And then coming into nowadays clean eating and then more hyper focused areas, personalized nutrition. Blood sugar regulation and managing your blood sugar is a new concept for a lot of people because we're used to thinking in terms of, good and bad, right? So if somebody's vegetarian, they think, okay, meat, and I'm not, and I know you're not, but just looking from their lens, okay, meat is bad, and then this is good, or this is good, and this is bad if somebody eats a particular way, like gluten-free or whatever it might be. But blood sugar regulation and paying attention to that, it almost is like, look, any diet can work for you, and every diet could also work against you. There's actually a ton of products that are on the market that are called keto, that when people are using things like levels, continuous glucose monitor, they're seeing that actually this thing is raising my blood sugar more than anything else that I'm eating right now because it's this processed snack that's there. So I'm very excited, and I'd love to get your thoughts on a personal level, as you've been monitoring your own blood sugar and making it make sense for you and your life and your level of activity. Have you been surprised at what things might move the needle in the right or the wrong direction when it comes to your own blood sugar management?
Yes, and I think it, more broadly, it is great information. We can all learn personalized medicine for ourselves based upon the input from wearables these days, and learn things like I didn't realize cashews were such an issue, and they were for me for whatever reason. Eating cashews bumped up my blood sugar. I also recognized that my blood sugar was not as ideal with not a really good night's sleep. So a lot of correlation between the metrics of my sleep, again, as determined by a wearable, and what I would see on my CGM or continuous glucose monitor. And I think, that's sort of the beauty of what Levels is doing, is allowing us to see it in real time and then to make those correlations. But, I think that what is most important is not to define the best diet for everybody. And that's been the trend. Everyone should be vegan. Everyone should be keto. Everyone should be paleo. And I think what is more valuable is to define the goals. What are we trying to achieve with our diets? Certainly, as you well mentioned, that control over blood sugar, keeping blood sugar in check, is a certainly valuable goal. If you want to take it further, then keeping uric acid in check, keeping other inflammatory markers in check, all well and good. Having a diet that caters to the gut bacteria, a diet that's rich in polyphenols, antioxidants, all well and good. But I think these days we have the ability to personally obtain the metrics that can then reveal the value or the threat imposed by the dietary choices that we make. That's the science part. There's a social part to our dietary choices as well. We leave that up to the individual. But all roads lead to Rome. I mean, we can adopt any of the popular diets and modify them to reach our goals. Like you say, what might have raised my blood sugar might not raise your blood sugar, but we can determine that when we're careful and we start doing a little bit of science and understand that we're all different. We all have certainly different genomes. We all live in different places. It's varying times of the year. Seasonality varies across the planet. And perhaps most importantly, aside from our genome, our microbiomes are very different and the array and diversity and numbers of organisms living in the gut are really influential in terms of how we interpret the foods that we eat and how it plays out in terms of measurable metrics like blood sugar, for example. So I think gaining that information through the technology that we have as individuals, apart from what we can get in the doctor's office, I think is exceedingly valuable. And it gets back to, earlier part of our conversation where we went somewhere else, but we were developing a dichotomy between just the notion of sort of living your life however you want and then hoping for an Alzheimer's drug versus really beginning to embrace the notion that our choices have huge impact in terms of our brain's destiny. And that's a wedge being drawn in our society right now, being, really tending to really reveal how polarized we are, that the mainstream would have us believe that, there's another drug down the pike coming soon enough that'll save us all, and getting excited about a drug that slows the progression by 32%. That all well and good, but I am not really interested in a drug that'll slow Alzheimer's progression by 32%. I'm interested in lifestyle approaches that can reverse that problem, for example, and put people back on their feet. And that is, again, in the realm of personalized medicine. What does that individual need? It's much more important to know the person who has the problem rather than understand the problem the person has.
How frequently and what spread is it changing, or what would be your recommendation if you're trying to improve it and you're making these lifestyle changes? How long should you wait to retest?
So I think in terms of uric acid, a couple of points. First, I think checking it at the same time of day will be important, and that would be in the morning, and that would be prior to eating and or engaging in activity. I think the night before, it would be good not to have engaged in, or the day before, some really vigorous physical activity. When you break down muscle by aggressive exercise, that'll raise uric acid. And I think the night before, it would be reasonable to have not consumed alcohol, because alcohol, like fructose, is metabolized into uric acid. So again, first thing in the morning, and keep in mind that fasting, prolonged fasting, will raise uric acid as well. So try to keep these variables constant. And I would say testing every 2 weeks to every 1 month would be reasonable. And finally, I think a good recommendation would be to cross-check your home testing uric acid kit with a bona fide blood test done at your doctor's office, just to make sure that we're talking apples and apples, and that what they get is pretty much like what you'd get with your home testing kit. I have found my home kit to be very reliable. And then, the modifications that you make over time will play out in terms of your uric acid, just like people have done with their finger stick check for ketones, beta hydroxybutyrate, and even blood sugar. I believe there's going to come a time in the future when we will have the ability to look at our CGMs and get a readout on uric acid as well. So just like you look at your smartphone and know what your blood sugar is right this minute, so too will you be able to look at your phone and get a uric acid measurement without having to stick yourself. I'm not keen on the finger stick, never have been. I play guitar. I don't want to damage my fingertips if I don't have to. But there are ways of doing it that I've learned that are almost painless and can get the job done. One little trick for your viewers is I tend to do the finger stick under a fingernail, like a thumbnail. And I don't really feel it as much when I do that, as opposed to just at the tip of the finger. And that seems to work.
That's a great suggestion. So you mentioned quercetin, vitamin C, tart cherry, those things being supportive in getting that uric acid number down. We talked about high purine, right? Purine was the term that you used, the foods that we want to stay away from. But if you had to rank in order of category of food, or either specific types of classifications that are most going to be concerns when it comes to uric acid, if you would give us a top 5, what would you list at the top, just so that everybody has it here and it's a takeaway that they could put out there?
I think probably number 1, 2, and 3 would be fructose.
1, 2, and 3.
Fructose and fructose. Below that would be purines, depending on the person, and then alcohol. By and large, if you look at the pathway, about 2/3 of the pathway in modern humans is being used to create uric acid from fructose. Fructose is a major player these days. We know that close to 70% of the more than 2 million foods that are find themselves on the grocery store shelves, those that carry a barcode, in other words, packaged, contain added sweetener, and most of that is fructose derived via very inexpensive high fructose corn syrup that increases the fructose content of the sweetener. Why? Because it's cheap, and fructose is much sweeter than glucose. So table sugar, 50-50, glucose, fructose, is being challenged with higher levels of fructose because it's sweeter, you can use less, and it's cheaper through the manufacture of high fructose corn syrup, obviously from corn, but from other sources as well. So, by and large, get away from sweet foods, get away from packaged foods. There are some sweeteners like allulose, for example, which oddly enough is an isomer of fructose that is not metabolized as fructose is. It doesn't raise uric acid, doesn't lead to fatty accumulation in the liver, doesn't lead to insulin resistance, doesn't lead to, I mentioned, uric acid increase, doesn't challenge our leptin and ghrelin control mechanisms for our appetite. So, allulose seems to be a reasonable choice in terms of a sweetener. But, by and large, it's good to kind of get away from catering and being responsive to, or at the mercy, if you will, of our sweet tooth day in and day out. That comes from a more primitive brain center speaking to us as a survival mechanism. Nobody on the planet that you would ask would tell you they don't have a sweet tooth. When I lecture, I say, okay, raise your hand if you don't have a sweet tooth. No hands go up. And it's true. Everybody has a sweet tooth. It's hardwired in. But we can override that primitive desire as we rein in our other primitive desires day in and day out, and realize that, okay, I think I would like to eat the chocolate cake, but in the long run, even in the short run, it's not good for me. It's not good for my metabolism. It threatens my gut bacteria. You name it. We can figure out the rationality. So we are able to override that. And the more we cater to our sweet tooth, the less easy it becomes to override it. So use allulose, use perhaps some monk fruit or stevia if need be. But I think getting away from really thinking that it's a treat to have sweets is the way we ought to go.
Yeah, whether with uric acid or where we're talking about blood sugar, the beautiful thing of if you can measure these things, if you can use something like a continuous glucose monitor and you have your baseline is at a pretty good place, then you truly have metabolic flexibility, because I know your work and I've seen you talk about this before. This isn't about eating, quote unquote, if somebody's listening here, perfect all the time. It's actually just knowing your baseline. Then when you know your baseline, if you so choose to have a glass of wine, occasionally with friends, and you're on a boat somewhere, as you were referencing your boat earlier, or if you choose to have a piece of chocolate cake because you're enjoying it for somebody's birthday, you have that metabolic flexibility because your baseline, where your baseline is, and you also know how you feel, how your sleep shows up when you are at your baseline. So it's okay, and it's not even a cheat day. It's not a cheat day. It's just you get a chance to enjoy it, and you appreciate and you love your baseline so much. You're like, okay, great. I had a little taste and I'm back to my normal world. And it's not about good and it's not about bad. It's just about feeling great. So on that note, any comments about that? And when you do go outside, like, do you have some, wine every so often? Do you have the sugar every so often?
You bet. And I think the big word I didn't hear you say is guilt. And we got to offload the guilt. I mean, you can deserve a glass of wine. Gosh, we go out to dinner. I'm definitely quite likely to have a glass of wine. Less lately, and it's not because of the deserving or whatever. I just don't feel well. I don't tolerate wine or any type of alcohol like I used to. So I for whatever reason, I'm becoming a lightweight. But the birthday. The thing is, I can get away from people because you look at the calendar. And it's always something. It's always somebody's birthday or anniversary or some public holiday, whatever it is. It's Canada Day, you name it. It's something. So, I think we have to rein it in. And some people talk about the 80-20 rule. And I think that's, in my world, way too generous. I mean, I don't want to eat 80% good food and 20% crappy food, because it's 20% crappy food that's going to get you into trouble. And you don't need to eat a lot of those threatening foods to have issues. It doesn't take a lot. I mean, a Coke, not going to happen. Glass of fruit juice, that's not going to happen in my world, because, that's coming from my higher brain that's really understands what fruit juice or sugar sweetened beverages do. I live and breathe it, so I know how threatening it is. My dad died of Alzheimer's, and so I don't want to do that to my kids, nor do I want to do it, nor do I particularly want to go through that. I don't want to die of the various things that are preventable by living the lifestyle that we talk about. And I'm not perfect, I assure you. And I think you're really getting at something I think that's important and is fundamental. And that is, we have to walk the talk as we stand before people and talk about what matters. We have to walk the talk. But at the same time, I think the message that no one is 100% is really valuable. Do I miss days when I should go running? I do take a day off once a week. But, frankly, I think that's actually a good thing. Have I stayed up late and binge watched something on Netflix with my wife? Yeah. And did I feel it the next day? I did. But did I enjoy it? Did I finally figure out how it ended? Of course. So, there are things that we know are not necessarily our best choices, but, it's all about balance.
It's all about balance, and then finding what that personal balance is for you, and then continuing to evolve it. Like you've said, you've mostly focused on teaching the same message over a period of time with small little tweaks. But when you came across new information, when you came across additional research, and it made sense to you, or you were getting it from a trusted source, you were willing to say, okay, let me try this. Let me explore this a little bit further and take it on and see if I notice the difference. That's the beauty of it for largely a lot of these lifestyle interventions that we're talking about here. There's not the side effects that are going to be there. So you can try them and you can put yourself on a protocol and a challenge and see, wow, how much better do I sleep if I just don't have alcohol this month, compared to before where somebody might have, a glass of wine a week. So that sort of challenging yourself and trying out those protocols is so important. And we can do that, today with all the great information. I want to get a chance to just come back as we're wrapping up here. We started this interview primarily going from, the latest research that's out there in the space of Alzheimer's and how diet is a central factor in that, primarily because of this component of blood sugar regulation and the impact that has on a whole host of things. But as you alluded to, there's a lot of other areas in Dr. Bredesen's research and some of the work that you've put together that also play a role. These different pillars like toxins, environmental factors, sometimes mold in the house, stress levels, the amount of community and love that you have. And actually you and your team made a whole docuseries on this exact topic called The Science of Prevention. Just give us the high level on some of the episodes that you cover there. And for anybody that wants to sign up and watch that, we have the link inside the show notes. But I think it's worth touching on because we spent so much attention on diet, which is well needed, but there's these other pillars that also relate to Alzheimer's and cognitive decline.
Again, there are a lot of inputs that are important, and we created the docuseries "Alzheimer's: The Science of Prevention," whereby we got the expert in each area to then present why that information is really relevant in an Alzheimer's prevention program. I had to pause because Alzheimer's prevention. Even the notion that here's this disease affecting 6 million Americans that is by and large preventable. And yet, people kind of assume that, if I get it, I get it. If mom had it, I got it. And that's the way it goes. There'll be a drug, hopefully, or not. But our lifestyle choices are incalculable in terms of their value to keep our brains healthy, functional, and disease resistant, including Alzheimer's. So we looked at sleep, we looked at exercise, we certainly looked at diet, we looked at stress, we looked at all these factors with, experts who are spending their lives researching the importance of these areas. We looked at the ability that our brains have to regenerate themselves through what is called neurogenesis and neuroplasticity with Dr. Michael Merzenich. As you mentioned, we did interview Dr. Dale Bredesen as well. Wonderful contributors who really bring information that's based on the best science available, but is presented in a way that you can then leverage that information. Okay, I get it. Maybe I didn't understand everything that he or she said, but at the end, I walk people through, okay, you heard that, maybe a bit complicated, but here's what it means for you in terms of what you should be doing now. And it means, for example, that you darn well better pay attention to how long and how well you are sleeping, as an example. I mean, who knows? How do you know how you're sleeping? Well, you wear a wearable device, and in the morning, it tells you that last night you got this much deep sleep, which is important for cleaning the brain out, if you will, this much REM sleep that consolidates our experiences into memories, how long it took to fall asleep, how long you were asleep, etc., as an example. So I think the purpose then of this presentation is to, present the data where we are today, but more importantly, then what do you do with it? What does each person take away from that in terms of, okay, I get it, and what do I change? So, that's so important that we step these concepts down to a place of understanding, but also to a place of being actionable by the viewer.
Hey, YouTube, if you enjoyed what you just saw, keep watching for more great content on how to improve your brain and your life.
So all of a sudden it became clear to me that there was this whole other field of foods that actually can activate your metabolism. What are those foods that can burn harmful body fat and unleash your inner metabolism?